The following is a presentation of the Six Arrows Radio Network.
Today on the Workbench, Listener Build Projects, Part 2. Welcome to the Workbench. I'm your host, George, KJ6VU.
And I'm Jeremy, KF7IJZ.
This episode of the Workbench is brought to you by Elecraft, makers of high-performance radios, amplifiers, and other great station accessories. Check them out at www.elecraft.com. And by Autodesk, the makers of Eagle PCB design tools, the software we use to design all of our Workbench build projects. For more info and your free copy of Eagle, go to www.autodesk.com/Eagle today.
Welcome to the Ham Radio 360 Workbench podcast, your bi-weekly deep dive into technical and making topics related to amateur radio. And I almost feel like saying we have a special treat because everything's almost back to normal. George?
Hey, Jeremy, back to normal, kind of in air quotes. How are you, man?
I am good, but I'm exhausted. I have been driving a lot today, and I've been up since 04:30 Eastern time, and it's currently 11 o'clock. So I'm at Goshen, Indiana.
What would possess you to go there?
So I am at the annual Midwest Rep Festival, which is a 3D printing festival in Goshen, Indiana, hosted by CME CNC, which is a company that makes Delta printers that is based out of Goshen. So I took the day off work today. I hopped in the car, drove the 4.5 hours-ish to get here from Cincinnati, arrived at my hotel, dropped my stuff off, got my portable rig, and immediately headed out to the vendor setup night, which is actually open to anybody who's attending. And it's been really cool. This is a really cool event. It's kind of started off small. This is its 5th year, but this year's a big deal because there's some pretty big names here. I got to meet tonight Joel Telling from the 3D Printing Nerd YouTube channel. He gave me a high five that I actually can still feel in my hand. I got to meet Brooke Drum, who is the proprietor of PrinterBot, which I chastised him because when we did our 3D printing episode, we recommended the PrinterBot Play as a good first printer. And, of course, then they were sold out of them. He wanted me to be very clear that they are back in stock. But, yeah, it's just really cool to see everything from these professional companies to these people who are building printers from scratch. I actually even met a guy tonight named Ray who designs his own 3D printer and CNC controllers in Eagle, and then has them manufactured in China and then sells them. Like, he designs them completely from scratch.
So is this gathering for more on the hobbyist end of the spectrum, or are there like professional type of gear there, or what's sort of the range of products?
So it's both. Some of the big manufacturers that are here that are very big in the industry are Lulzbot is here. Of course, CME CNC is here as the host of the event. PrinterBot will have their new Simple here. A couple of filament providers like Matter Hackers is here. E3D, who is a major hot-end manufacturer and extruder manufacturer, will be here tomorrow. Joseph Prussia, the founder of Prussia Research, the father of probably the most popular RepRap printer, the i3. Of course, we talked before about the i3 Mark II as a recommendation. He will actually be here tomorrow, which is huge. But then you also have people like Ray who are just really passionate hobbyists. There was a guy I met tonight who actually 3D printed a guitar, and there were people actually playing it. It was a 3D printed, like kind of Telecaster style. And it was amazing.
Wow.
So, yeah, it's both industry and hobbyists.
Well, that sounds like a lot of fun. And it's in that location because one of the manufacturers is located there?
Yes, that's exactly right. There's nothing particularly special about Goshen other than the fact that CME CNC is here. But
do they have any kind of like user contest things where people could show off their design and printing skills?
So I wouldn't say contests. But I mean, there are a lot of people here who are showing off different printer designs. And actually, that's the thing that's interesting. So, I mentioned Joseph Prussia was here. He's from the Czech Republic. There were some folks from Germany, there were some folks from Canada, some other folks from Europe. I mean, there's a lot of people from all over the world here. If you look at the parking lot tonight, there were also license plates from nearly every state. I mentioned Joel Telling earlier. He's from Seattle. I mean, there's just a ton of people here, and they say this is going to be the biggest one yet. But what is cool is it was very much it reminded me a lot like Dayton. I mean, it was just a lot of passionate people and some old friends coming together, just sitting out and totally nerding out over 3D printing.
That sounds like a lot of fun. Hey, did you see any of the printing of stuff that's not the plastic, but the more exotic kind of material?
So nothing like no metal type printing, but there are several people here who do have SLA resin printers.
And like, what's an SLA resin compared to the normal filament?
In terms of what?
Well, it's different material, but it probably has some different characteristics, like it's harder or something. Yeah,
so I mean, it's a liquid resin that gets poured in a vat. It is exposed with UV light to harden it, and then a build plate moves through the liquid, and your solid appears.
So it's not a filament at all. It's a completely different printing process.
Yes, it basically exposes the top layer of the resin, and then the bed moves up, and it continues to add on to it. But the resin is very expensive and very toxic, but the print, your quality can be much higher. And the material is a lot more durable, and you don't have like print lines in them or anything like that usually. So it's pretty cool.
Well, it sounds like a load of fun. Now, were you shopping around for something, or were you just kind of hanging out?
This was kind of a lark or a boondoggle to come up here. If I get anything interesting to share in a future episode, I will. The fact of the matter is, as I had mentioned, I had canceled my Prusa Mark II order. And one thing I do want to say to follow up on that is that recently they announced and are now selling the Prusa i3 Mark IIs. And the Mark IIs has some upgrades. First of all, the linear bearings are now attached with U-bolts. They've upgraded the bearings. And then one of the major, I don't want to call it a manufacturing defect, but one of the things that made me cancel my order had to do with some wiring issues, and they have been intentional about addressing those wiring issues in this current version. It's the same price. It's not like it's not more expensive to get the Mark IIs. Like the Mark IIs is just the model that's available, and if you own a previous model, you actually will be able to buy an upgrade kit for about $50 plus shipping to upgrade to the Mark IIs.
Oh, nice. Now, do they sell that through dealers, or do they sell it online only?
He sells it online only, direct from him. The printer that I'm actually going to buy, so there's a gentleman here named, Mark or Mike Hackney, I can't remember. I talked to the guy for a very long time, but there is a Delta printer, which I've been eyeballing and almost ordered 2 weeks ago, but I knew he was going to be here, and I wanted to see his. And a Delta printer, imagine, if you will, there's a thing suspended in space by 3 sets of rods, 120 degrees apart. And rather than having an XYZ axis that get independently moved, it uses smarter math to move these things up and down, which push it around. Just go Google Delta printer. Anyway, it's a much larger build area. It's a 300 millimeter, basically cylinder that goes up to over 400 millimeters tall. It's huge. The printer itself is like a meter plus tall. It's just a giant printer. It's available as a kit. It is called the Ultibots D300. It's sold out of Florida by a gentleman who runs this business as a part-time. It's interesting because it's a kit, right? So you have to assemble it, but there's no instruction manual for it. Like that's the guy has been so busy, he hasn't had a chance to build one. There's enough of a guide, you can kind of figure it out. But the guy I talked to tonight is actually getting a kit from them to assemble, and he's going to formally document the process. So I will actually be ordering mine after we're done recording tonight, because the quality of this thing is ridiculous. It's $1,000, and it's a lot of printer for $1,000.
Well, it sounds very interesting. So that is one you're getting.
Yes, yeah, I am definitely have decided that's the route I'm going to go.
Wow, very neat. So what are you going to build with it? What's the first big project?
So at Halloween last year, my daughter dressed up as Hermione from Harry Potter. There's somebody who released on Thingiverse a very beautiful Hermione's wand model, and I couldn't print it full scale, and I had to print it really small, and I handed it to her, and she says, "Daddy, why is this wand so small? And I said, because Daddy needs a bigger 3D printer, sweetheart.
Go tell your mother.
Actually, her mother was in the room.
As if on cue.
One of the other cool things, though, about being here is a couple of companies whose filament is really high quality but very expensive, and often very expensive to have shipped because some of it is sourced in Europe. But there are representatives here selling it, so I'm excited about getting access to some really high-quality filament at a little bit of a discount, but more importantly, not having some of the expensive shipping. So that's another really good benefit of being up here this weekend.
Well, it sounds like a lot of fun.
I'm enjoying myself so far, but ask me again tomorrow because I will be there all day from about 10 o'clock until, I think, 6, and then there's a giant party at a Chinese buffet.
Well, yeah. It is like a ham fest.
Indeed, it is. So
very good.
So I'm literally coming to you via an iPad and a very silly sound setup, but it's working. So that's why I don't sound like my normal self. But gosh, George, it's been 6 weeks.
It's been a while, yeah, since we've done a live recording together at the same time.
So what have you been up to?
Well, over the last, month plus, I've been really busy with a lot of work travel. So I had a trip to Europe and another trip to Japan. So things were pretty busy. The only ham thing that I could say out of all that was when I was in Japan, I flew out on Saturday. So Saturday morning, I get a chance to go to Akihabara, which is one of my favorite destinations to go look around. And in a way, kind of sad to report that there is fewer and fewer stalls of components and all that good stuff that used to be there. There's still some of that, but it's not what it used to be. But I did stop in one of the bigger ham radio stores and took a look around. Funny thing is, pretty much everything you see in Japan is the same stuff you could buy here. So there's really not much motivation to buy anything when you're over there, but it's kind of fun to look around. But that was kind of the extent of it. I took my D-Star hotspot and HT with me, which I could use in Europe, but legally could not use it in Japan because I don't have a reciprocal license for Japan. But I was able to connect in to the various reflectors on D-Star and listen around a bit. So that was fun. But just a lot of work travel, so things have been really busy. And happy to be home for a bit, so looking forward to that. And I was looking forward to getting together with you and recording the episode finally.
Yeah, it is nice. And actually, in the last episode, which was Listener Projects Episode 1, I had commented that things will get back to normal in this episode. And as it turns out, as we were planning for this episode, that's not quite true because there's a lot of things that have happened in the last 6 weeks that we want to catch you up on. But we decided that rather than waiting till time in the future, especially since I ended up traveling this weekend, I didn't expect to actually be up here on Friday night. I was originally going to go on Saturday, but some things changed with my schedule that worked out that I could come up. So we're going to actually do listener episode part 2. But before we get into that, there's just so many things we need to catch you up on.
Well, why don't we do a quick run through some of those things now? How about a Dayton update? We got our stuff together for Dayton.
Yes, we have. So we have been assigned officially booth 6501, 6502. This is going to be in the tent building. Now, I cannot react to this as either positive or negative since I've never been in a tent building at Xenia, and neither has anybody else. The nice thing is we are very close to the entrance and the bathrooms, and we are at the end of an aisle, so we expect foot traffic to be good. The shorthand is to the tent that we are in, or the building, if you will, is the same place that the ICOM Emergency 1 vehicle will be set up.
Which should be interesting. I'm looking forward to seeing that, actually.
Yes, I am too. I've seen several videos on it. It looks pretty cool. And apparently they're not kidding when they talk about that it's basically interop on wheels.
By the way, if you want to look at where the tent is located, just bring up Google Earth and zoom in on the fairgrounds, and it's where there is nothing. There's a parking lot, which is where the tent's going to go, so you can't see it, even on Google Earth.
So, and to say about Dayton, I am really looking forward to it, mainly because I was fortunate enough to get to experience old Dayton, I think 4 years, thereabouts. I am really looking forward to discovering, because you always had that mental map when you go to Dayton of what you're going to go see and where people are, and people didn't move around. So I'm actually kind of excited about the change of scenery. I already know there are going to be problems. There are going to be things that won't go as you want them to. There will be people complaining, but I personally am going into it with a completely open mind, and I'm going to just ride through it and be excited to talk to vendors and see our listeners.
Well, it's a huge effort. I can't even imagine trying to put on a show like this with 24,000 or whatever attendees. It's just, enormous for a volunteer organization. So, undoubtedly there'll be challenges and all that stuff, but, everybody's kind of have to just go with it because, we want to support the Dayton guys and, more power to them for keeping it up. And, we're grateful that they do it.
And as we did last year, we will again be doing day-by-day coverage of the Dayton or Xenia Ham Zine-vention.
The X-vention.
The X-vention, yes.
So we're gonna be out doing a bunch of interviews, but we'll also be hanging out in the booth. So come by. You never know. We may be there. We may be out and about, but probably actually, about half the time.
There is one time we know we'll be out and about.
Oh, that's right. Saturday at about 2:30 in the afternoon. We're all going to be in a forum session, and the forum folks were kind enough to offer us a very prime time spot at about 2:30 in the afternoon in the large forum room. So do you know how many people this room is going to hold?
No, how many?
450.
Wow.
It's an enormous room, which means we have to pack that thing because they're expecting us to be a draw. So I don't know if you're listening to the show and you have any thoughts of coming to Dayton, please come to the forum event on Saturday. We'd love to see you there. And the theme of the forum event is a combination of building stuff and talking about some of our build projects and just sort of all things workbenchy. And
but with a very operator twist.
Yes, actually, that's a good point.
An operator. It's not just. In other words, it's not just going to be rehashing material you've heard on the podcast. We've actually put together a session that mixes things from the podcast with legitimate operating, and we look forward to actually putting this together and then presenting it to you.
So, in a way, I think some of that is you can think about it as practical tip. Some of the topics will be antennas, batteries, and other operating accessories for operating in the field and portable in general, for sure, and a bit about building stuff, and just a chance to meet everybody and say hello. And Cale's going to be there to kick it off, and then Jeremy and I are going to flip a few slides, and we'll chat and take some questions and have a great time.
Yes, we will. So I'm looking forward to that. I can't believe I've gone from Dayton Virgin to presenter in like 5 years. That's pretty cool.
Well, you're lucky you.
Well, make that determination after the session. If 5 people show up, I guarantee it will be our last opportunity to do this.
Well, last year we had a lot of people come by the booth, which was really a total hoot. So we're looking forward to that. So please do come by the booth, say hello, and stop by and chat. This year, the booth is going to be 2 booth spaces wide. So we have quite a bit of space. So that should be a lot of fun.
Outstanding. So that's Dayton. Moving on, oh my gosh, so many new things have come out or been announced.
Where do you want to start?
Let's start with ham radio stuff first. So, George, you mentioned as we were talking that there's news about the new ICOM 7610, which is basically, as has been reported, is the SDRE 7300, but with even more stuff.
Yeah, it's a 7300 on steroids, and it's probably going to come out at twice the price. I don't think this is going to be a cheap radio, so I'm guessing it's going to be in the $3K kind of range. But think about it as a 7300 that has multiple receivers and lots of advanced features, a bigger display, and
it actually has a video output, so you could plug it into like a 65-inch television.
I think it's a VGA, well, maybe HDMI or VGA.
I thought it was HDMI. Of course, they're not officially released yet, so
yeah, we don't know. But that'll be kind of nice because you can take that nice display. And on the 7610, I think it's a 7-inch display to begin with, so it's pretty good sized.
Yes.
So this is really a long-awaited radio. The 7300's been super popular. Everybody I know that has it loves them, and the 7610 will be that and then more. They've been talking about the thing for almost a year now, so it seems like it's forever. And the rumor has it that they should be available in the next few months. A lot of the retailers are taking deposits now for them. So if you want to get in line and buy yours, you can probably put $50 down and hold your spot in line. So we'll see how it goes. I'm tempted. If I do buy one, I have to sell some other stuff first. So it's not going to be a freebie.
If you didn't sell your 7600, you may have missed your boat on that.
I looked around and yeah, of course the price is going down, but I love my 7600. It's a nice radio, although I frankly haven't used it that much. I use my K3 as my normal HF rig, but I really should sell it and look for an opportunity to get the 7610. Maybe we'll see. So I think ICOM did a really fantastic job coming out with their first generation. A lot of times when you come out with a new architecture, a radically new, different architecture, it's hard to get everything right because there's so much to do. Getting the core technology to work all the way to the user interface and the features and all that. But boy, from what I've seen, Jeremy, everybody that I know who has the 7300 is very, very happy with it.
Oh, I love mine. And the other thing that I think they're to be commended on is the fact that normally when you do have a major architecture switch like this, you would normally see this rolled out in the high-end equipment first. And for them to start with their low-end everyman radio was very nice.
Although, the Kenwood 590 is a very good radio. I think performance-wise, it's probably similar. Maybe the 7300 has a slight edge on it. But boy, feature-wise, the 7300 just looks like such a modern radio. The kind of features you would expect to see. So I'm sure they'll do really well with the 7610.
So speaking of new ICOM radios, another new ICOM radio was announced, and this is the 7400. The 7400 looks like it is going to be the replacement or the upgrade for the ICOM ID880. So it is going to be a D-Star radio. Looks like it will be single receiver. The faceplate for it looks exactly like the 880, but with the high contrast black text on white background. The other notable thing about this radio is it is said to have these new features available in the ID51 Plus 2, such as the hotspot mode and I forget what they call the terminal mode, which basically, again, with the right D-Star software in the back end or what you're connecting to, allows you to use your radio as either a DVAP or a DV dongle. So that's pretty cool. No, I don't think I've seen word on pricing or availability on that just yet.
And what's the model number for that?
7400.
Because there was a 7400.
No, I lied to you. There still is a 7400. It is the 4100.
Oh, 4100. Okay.
Yes, because the flagship D-Star radio is the 5100. I'm sorry, this is the 4100. I'm blaming sleep deprivation.
Fair enough. Yeah, I was just looking it up. I haven't seen that. That was news to me, but happy to see a new one. Yeah, it looks like an 880 with just a different, like a bitmap display.
Now, actually, what's kind of cool about this is, if you are wanting to, I'm sure we have a lot of listeners that build Go boxes, and it's very difficult to put every single kind of radio in there. But if you're really trying to build a box that has a lot of digital capability, what's nice about these single receiver radios, they tend to be cheaper. So this would give you the single receiver D-Star radio. I don't remember is it the FTM100D is the Yaesu System Fusion mono receiver radio, but it has fusion capability. Does that sound right?
Yes, I think it's FTM100DR probably.
Yeah, something like that. So, I mean, if you wanted to build a box that was the Rosetta Stone of radios, throw in a DMR mobile, and you are virtually set. But it's nice to see them come out with a single receiver option of this D-Star radio.
Yeah, I wonder what the price point is for this. It's probably around what, $350?
I'm going to guess $350, but that's pure speculation. We have no knowledge, and I haven't seen anything online. I'm sure if our listeners know, they will let us know.
You know what I wish they would come out with?
What's that?
I wish they'd come out with a new 1200 meg radio to replace the ID1, because they discontinued the ID1 and there's no replacement for it. And the thing that was very cool about the ID1 was not that it's a 1.2 radio particularly, but that it had the TCP/IP transport built into it so that you can make a reasonably high-speed data radio out of that thing. And they discontinued it, and there's nothing else in the portfolio. And I don't know if they're going to come out with a new radio like that or not, but you'd think they would.
Well, here's the question. Are they still selling the 1.2 DV module and the 1.2 DD module?
Yes, they are.
Well, then maybe they will.
Maybe, yeah. It's odd. They still list the ID1 on their website, which is kind of weird because you can't buy one.
Well, the 7200 made a comeback.
Yeah, that was just sort of on pause. Hey, I'm using my 7200 for field day. That's going to be our 20-meter radio.
Oh, really? I didn't know you had a 7200.
I do. I bought it for field day, and because it's kind of ruggedish. Have you ever seen the Gigaparts custom paint jobs?
I didn't realize. Oh, yes.
This is the coolest. OD yeah. This is the coolest thing, and they don't do it anymore. And I don't know why, because I'm sure people would buy it. So if you guys never saw this before, the 7200 is an HF radio that kind of looks military-ish. It kind of has that kind of beefy feel about it. And Gigaparts, who's a radio dealer, had a special deal where they would paint the chassis. They remove all the knobs and all that, and they paint the chassis. Instead of black, the standard color, you could get it in like 4 different colors. You can do like army olive drab. You could you could do it in like that digital camo in a couple of different colors, like a desert color and a jungle color. Anyway, I think ICOM had them do it as a promo thing for a trade show, but then they sold that as a upgrade to customers through Gigaparts, and they don't do it anymore. But it is the coolest looking thing.
Yeah, actually, I saw when I got my license, I saw that display. They had the green one, the black one, which is the standard, and then the Desert Storm one, cookie desert chocolate. I think they call it chocolate chip camo. And they had gotten a gentleman to do that for them who did custom paint jobs. And I thought Gigaparts had found that guy and basically employed him to do these. So I think that maybe why they don't do them anymore is maybe he just got tired of it.
That could be. But I think they were selling it up to a year or two ago, and then they stopped doing it. But I bet they would have more business than they know what to do with if they would start doing that again.
That's it for radios for this week. Actually, there's a ton of other new stuff on the DMR front and whatnot that's come out, but need to collect our thoughts on it because it seems like everybody and their brother. I saw Oshin has released one, and there have been a couple of other ones that have popped out of the woodwork. But we'll learn a little bit more about that and talk about it in the future. Now, on the making front, holy cow, has it been an exciting few weeks.
Yes, with lots of new Linux boards coming out.
Yes, 2 in particular, one from the BeagleBone camp and one from the Raspberry Pi camp. So,
have you had a chance to look at these things?
Actually, I have purchased 2 of the new Raspberry Pi. So what I'm referring to is we're all familiar with the wonderful $5 Raspberry Pi Zero. The first upgrade was they put a camera connector on it. The second upgrade is they now sell the Raspberry Pi Zero wireless. And if you're one of our listeners and you're hearing this from us for the first time, then you don't get on the internet very much because everybody's been talking about it.
So what's the big highlight difference with the W?
It's wireless. It does have Wi-Fi on board. And what's actually really kind of cool about this, so I've been fortunate enough to get 2 of these. They cost $10 instead of $5. So that wireless feature is doubling the price. But one of my coworkers built a series of security cameras using Pi Zeros and the Pi camera modules. What's cool is now that Wi-Fi is on board. You don't have to go and get an external on-the-go cable to plug into a Wi-Fi adapter or anything like that. It's actually on board. Also, with this release, the Raspberry Pi Foundation released a new case for the Raspberry Pi Zeros that have the top lid is there. I think there are 3 that come with it. One that lets you mount the camera module and has a little aperture for the camera. One that has a cutout for the GPIO pins, and one that's just a solid top. So that's kind of cool to have a case that gives you those different options.
So I got a question for you. Since the only connection to this thing for network is Wi-Fi, you have to have some kind of console connection, maybe through the USB port, where you can get in and configure it, right?
Well, that depends. Technically, you could configure on a Raspberry Pi 3 and just save the image and load it. You could use a console cable through the GPIO. You could still use a wired connection. But overall, sorry, I'm skirting the real question here. So the Raspberry Pi Foundation put a feature in Raspbian that you can actually put your wireless network settings in a WPA supplicant file in the boot directory, which is readable by any Windows or Mac computer because it's FAT32 or FAT, I don't remember. But you can actually put a file with all your wireless network settings in there. Then on boot, it will load that file and put your Pi on the network for you without having to actually get in there and configure anything first.
Oh, okay. But if you handed this thing to somebody else and you didn't know what their access point or password was, they would have to have some way to log in.
Yeah, they either with a monitor and keyboard or something. Yeah, it's just like every other Pi.
Mm-hmm. Yeah, it looks really nice because it's tiny. It's half the size of a Raspberry Pi, but it has this gigantic set of solder pads where the GPIO header goes, so you can physically interface it to stuff. So I think for an embedded application, it looks really cool. Yeah, they're only $10.
Well, that's with wireless. Have you never seen a Pi Zero?
I've seen the Zero, but I haven't. I haven't been that attracted to it, mainly because I always need to have some kind of network connectivity, and so that hasn't really been that useful for me. But this one looks pretty cool. I actually wish they would also wire out the pins for Ethernet, and you could put the magnetics and all that on a separate board, but it'd be kind of nice if they brought that to the header. Well,
there's no Ethernet on that chip.
There's a reason why.
The Ethernet on the Raspberry Pi 3 is if I remember correctly, the USB chipset and the Ethernet are all kind of in one. Now, you can get Ethernet SPI chips. In fact, actually, Dave Jones from the EV blog has this video where he's talking about building a Raspberry Pi cluster. And rather than, I felt like he was directly attacking me for my cluster, but he's like, rather than having a bunch of Pis with network cables into a switch, he was actually considering building kind of like a motherboard that Pi's plugged into via GPIO, where he would just get these SPI Ethernet chips. And then you can also buy basically a switch on a chip. And like you said, all the magnetics and electro and the decoupling and all that stuff you don't need because everything stays at signal level. And so he would basically have those Ethernet chips talk directly to a switch, no cabling involved, because you can buy a switch on a chip. So technically, you could do it that way.
So this thing looks like it's more useful in general. I mean, it's for such a small thing with all the GPIO, and it looks like it's got a couple of micro USB connections. I presume one's for power. Maybe one's for
power, and the other one is
USB.
It's on the go USB. Yes.
Oh, okay.
Or there's things you can do with a Linux kernel to make it look like a gadget. So, for instance, you can configure it so that if you plug a regular USB cable into it and then plug it into, say, a Windows machine, in the device enumerator, it will look like an Ethernet interface because it is in USB gadget mode. But that is beyond the scope of our introduction for this show.
Right. Very good. Well, what else is out there?
So the other thing that was interesting, and actually I hope to learn more about tomorrow because representatives from beagleboard.org are actually here at Midwest RepRap Fest. In fact, they have a table full of drones and some other robots. And what their latest product is, so there's, for things that are the most commonly used maker boards, there's the BeagleBone Black, which is about, what, George, $40?
The standard one is $55, and then there's one that's wireless for about 60 something.
Yeah, 60.
And then there's cheaper ones. They go down to as low as about $38, depending on which version.
Well, they've released a new one called the BeagleBone Blue, and the kind of the focus of this one are for people doing motion control and robotics applications, because basically the board has a lot of motor drivers built into the board.
So that makes sense for being at the printer show.
Yes, and granted, I will admit I know very little about this. You and I were talking before. Obviously, to get the most out of this, there's probably a heavy reliance on the microcontroller processors on the board. The default board itself is this Linux computer, but we've never really talked about actually programming the microcontrollers on there. Because it's not like it's Arduino compatible. You actually, I think, have to understand how to actually program those.
Mm-hmm. Yeah, it's not trivial. I mean, you really have to dig into the specs and all. But it depends on the application. You could do semi real time stuff even without the microcontrollers built into it, just with the normal processor. You just don't have a deterministic loop control time, so it's a little bit. If some big process kicks off, it might slow other things down, and if you have some super time critical application, that's probably not a good idea. But you could do a lot with that. I mean, just like you can with the Raspberry Pi, frankly. I mean, it has some GPIO. You can actually talk to the physical world through some buffers and whatnot.
Yes. Actually, we didn't cover it, but there's also the Raspberry Pi compute modules have been released, which are basically SODIMM form factor, which is the memory that goes in your laptop. And I didn't realize that the CPU actually has a lot more GPIO than what they put out on the board.
Not surprising. I mean, that's true. Even on the Beagle, there's more I/O on the Satara chip than there is header pins.
Well, that's one of the interesting things from a design perspective, right? It's a trade-off between cost and size.
Right. Well, functionality and how many pins do you really can you really get away with? And it just makes everything really big. If you don't need too many, it's kind of too many. But it's always every design is a big trade-off.
So that's it for micro-E type stuff. I'm sure other things have happened. So have you ever heard of Tindy?
Yes, I have heard of it. I haven't really shopped much there, but I've heard of it.
So, George, tell us what Tindy is.
Tindy is a online shop. What do you call it? Like it's kind of like Etsy, but for geeky stuff.
Yeah, actually, that's a really good way of putting it. So, if you design a board, let's say you design a board that debugs something that's really handy, you have the ability to make small quantities of them and put them out there for sale, just like you would artwork or crafts on Etsy.
Yeah, exactly. Have you poked around there very much?
So I started following Tindy on Twitter and quickly became overwhelmed because it's really interesting how many products that they will showcase and how they run the gamut from hyper specialized to generic products. Like I've seen everything from, again, like this is a specific debugging tool for this specific thing, all the way to, oh, look, I've created a new form of at Maltinsi type thing. Mm-hmm. But it's really interesting. Like I've come across a couple of FM like radio modules on there. I've come across some like data radio modules. It's really interesting. So I bring it up because much like people who spend time searching through like Alibaba or eBay for interesting electronics boards that do things, Tindy is another source for those.
It's fun to look around. If you want to build a project, I could see where you might have something in mind and you want to make a circuit board and you're thinking, well, by the time I go through the trouble of actually making the board and I need one, I'd like to maybe defer some of the cost. And I know what, I'll sell them to somebody else. Well, where would you do that? You could do it on eBay, or Tindy is really more targeted towards that kind of customer who's looking for a special little circuit board that has some, interface on it to plug into a Raspberry Pi or whatever.
So that's it for boards. I mean,
yes.
we could actually start a show just on boards that people have created this week.
I have something else I want to tell you about. Speaking of boards,
do tell.
So when we got our booth at Dayton, as you said, we got booth number 6501 and 6502, and I mentioned on the Facebook page that if you're a listener and you're old enough to remember the old digital days, the number 6502 will be significant. Do you know why?
Is that a Motorola?
No, it was it was close. It was a processor.
Yeah, an Intel
back from the 70s.
Okay.
No, it was made by, I think, by MOSTEC, MOS Technologies or MOSTEC, one of the two. And it was super popular. It was probably one of the top 3 8-bit processors at the time, along with Motorola and Intel. And it was the processor in the original Apple II. Now, the reason that I mention that is because somebody has made a recreation of the 6502 processor using discrete transistors on a gigantic circuit board. And
that's amazing.
It's a labor of love, to say the least.
Oh, clearly.
So you have to go to the website to check it out, and it's called monster6502.com. And it is a thing of beauty. And I don't know who did this, but it is awesome. So when you get a chance, go check it out, monster6502.com.
You know, it's interesting because didn't somebody also design a 6502 in Minecraft?
Well, I don't think they did a 6502, but I've seen like ALU, arithmetic logic units, essentially like math functions, or like a four-banger calculator done in Redstone in Minecraft, of course. I've never done that, but some people have a lot of time on their hands.
Yeah, I really appreciate that's one thing America does very well, is we did it because we could.
That's right. So apparently these people have a lot of discretionary time and nothing else better to do.
And probably some discretionary money.
That too. Anyway, check it out, monster6502.com.
Hey, George,
awesome.
Put that in the show notes.
I will, Jeremy.
Outstanding. Yeah, that's actually, so I get a break from show notes. I've already done my part. It's so wonderful.
You're done. Well, you're on special assignment.
I'm in Goshen, Indiana.
And because of that, you get to skip out on that. Hey, one last thing we should talk about before we wrap. We've got some build project update.
Go for it.
So the antenna analyzer continues to be popular beyond our wildest imagination. So I think at this point, Kale sold something like 400 or 450 antenna analyzer boards. So I hope, since the kids are packing the envelopes, I hope he's paying them. But anyway, so that's been sold out for a couple of weeks, and so I pulled the trigger on another batch of boards. So he should have a batch of 100 boards in the next week or so, and we're going to make a pile of boards to bring with us to Dayton. So
that's awesome.
Either get them over through the mail or come to Dayton. So that continues on. And
then we actually have some updates for project number 2 of the low voltage, what we've been calling the low voltage disconnect. But truthfully, I think we should save those for another show. Like, I think it may be time to actually do a show on this project.
Yeah, we'll do that. We'll go into detail. Just to tempt people along here, we haven't forgotten about the low voltage disconnect, and it has that and the power gate type of functionality built into it without a charger. So no charging circuit.
Now, you had mentioned that you had gotten another batch of prototype boards.
I did. So I made the first board, and when the board showed up, I went to solder the little linear technology chip on the board, and I realized that I had the wrong footprint in the layout, and the footprint was like 4 times bigger than the actual chip that I had. So there's no way in the world that I could make that work. So I had to make another circuit board. So the second circuit board came in with I'm sorry, the second circuit board was the one that had the smaller footprints, or the too big a footprint. So I had to send off for a new one. So that's off at the fab, and I'm going to get new boards probably in a week or two, and hopefully that will work.
This reminds me of the scene in Monty Python and the Quest for the Holy Grail, where he's talking about building castles in the swamp. But the fourth one
that fell over,
caught on fire. But the fourth one, well, you're standing in it. I'm sure we're being cursed for misquoting Monty Python. So, George, you had some sad news.
Yeah, I had a very sad week because our local ham radio store in Sunnyvale, California, in the middle of the heart of Silicon Valley, the ham radio outlet store closed this week.
Now,
and it was a sad, sad day.
Are they moving, or are they aren't they moving to Oakland, or do they already have an Oakland store?
They already had a store there. So there were 2 Bay Area stores. So Oakland is about an hour's drive from where we are. And so there's 2 stores in the area, which was great. and both of them have been around for a very long time. And the Sunnyvale store closed because the landlord jacked up their rent, and Silicon Valley is hot at the moment, so it's hard to find reasonable rent. And so they decided it wasn't worth it, I guess, to keep the store open, so they closed it.
Well, that's sad. I know I don't have a lot of sympathy for you, only because when I lived in Seattle, my nearest ham radio outlet was like a 3.5 hour drive to Portland.
Yes, well, we are lucky in that we do have one we can drive to, but it's an hour away, so through Bay Area traffic, which is not fun. So we're sorry to see them go. We really we're lucky to have a store this close by and just a wonderful group of guys there that we could go by and shoot the breeze with, and talk ham radio and maybe even buy something. So
maybe if you guys had done it in the other order, they could have afforded the rent.
They would still, yeah. Well, no doubt.
I'm kidding.
No doubt.
Kidding. I know that's hard, especially when it's real estate that's driving those types of decisions. So that's sad.
It is, and they really were in the middle of town. I mean, so it's not like they're in the sticks and the price went up. I mean, they're in the middle of the valley here. So great spot, and sorry to see them go. So I guess that's the way it goes. So that was kind of sad, but on a positive note, I would say that I'm excited about Dayton, as we've been talking about that, and I'm excited about Field Day. We're already doing our planning for Field Day, and we'll probably do some Field Day shows in the coming months before Field Day and talk about gear and whatnot. So looking forward to that. So there's all kinds of fun ham stuff in the future.
Oh, yeah. Actually, one of the things that we've talked about doing is before Dayton, we will know about how to populate your workbench from the flea market.
Yes, that sounds like a great idea. Hey, by the way, are you going to do some interviews at Dayton in the flea market?
If the opportunity presents itself. I mean, in years past, right, we've had certain vendors that were in the flea market only. Especially the first year I did this, I definitely did not have the manpower to single-handedly go out and do it. It's not for lack of wanting to. It's that there are two of us, plus we want to make sure we're spending time in the booth with our listeners as well. So we'll take a look at who's out there. Or actually, listeners, if there's somebody that you know is going to be in the flea market you would like to have us talk to, shoot us a note, workbench@hamradio360.com, and we will try to get them on our list.
Hey, Jeremy, so what's on your workbench?
So absolutely nothing ham radio or electronics related. Nothing.
Well, that was quick.
Well, I mentioned this in last week's episode. I'm currently, when I have time, I'm spending time at my other workbench in the basement, which is my woodworking workbench.
And what are you making? A QRP transceiver?
Yes, out of wood shavings. No, the drawers in my kitchen were, even though they look real nice and they have very nice hardwood fronts, the drawer boxes themselves were made out of pressboard. They're a little over 10 years old. The faces had pulled off a couple of them. I called the manufacturer and said, I would like to buy an X length of the material that you use so that I had the matching veneer, or it's really contact paper, but the same matching wood grain contact paper as what I have today. And they said, sure, we'll sell you that board for $80, or you can buy a new drawer for $150. And I was like, thank you, but no thank you. So I went out and got some quality Baltic birch plywood from a local, it's a national chain, but the local Rockler. Baltic birch is really awesome. It's very popular in Europe for furniture making, but what's nice about it is more plies than American birch plywood. So like a half-inch piece has, I think, 9 plies, and the veneer layers are like 1.5 millimeters thick. So it's like a good heavy veneer. The stuff is designed to be sanded and finished.
Now, the truth is that you said, honey, I'm going to make new drawers for the kitchen. And the whole time you're thinking, I'm making a to-go box for my radio gear, and I'm going to practice on my kitchen first.
No.
And buy all these cool power tools.
Yeah, I bought the power tools last year because I wanted to start making shelves. No, I know a lot of people make their go boxes out of like plywood. I'm not interested in that. The go boxes that I have are made out of rat cases, which I just much prefer. But I'm not judging. It's just like orange is the right color for a Go kit, not green. And I don't know. I'm not judging. It's just my preference. But admittedly, my wife gets a little mad because I'm really having fun doing this chore. And so my wife's like, that shouldn't count as a chore because you're enjoying it. I was like, honey, I'm doing it for the house. Whether I like it or not, I'm doing it for the house.
Besides, I saved $75 on that drawer.
Yes, by spending, $600 on tools and materials.
We don't go there.
I love starting a project that requires you to buy tools.
Don't they all?
Well, yeah. Well, I mean, at some point you have enough to start. But you can always find one thing to be like, what would make this easier? If only I had a blank.
Yes. I've never found a project that didn't need a new tool.
So, George, what is on your workbench?
Just a couple of lingering projects. I got a new version of our repeater control system board that I need to finish off. The design's done, and I'm waiting for some feedback from some of our very smart users who have very particular features that they want. So waiting for that, and working on the build project. And actually, the low voltage disconnect board, and we've got a build project number 3 in the wings, and I've been playing with some design ideas for that we're not going to talk about yet. So that's kind of it. Just getting that stuff put together and working. Trying to do that between all the travel has been a challenge. With Dayton and Field Day coming, it'll still be pretty busy time, but we want to get as much of this build project stuff done and ready for Dayton as we can. Yeah, because the goal is to keep you guys busy with projects for a little while to come. Man, we've caught up. We've gone through newsy stuff. We've talked about our workbenches. I think it's time we finally get into listener interviews part 2. Yeah, so give us the quick rundown of who you talked to and what they were talking to you about. All right, so I had 2 more in this round. Number 1, I talked to Jeff, KK9JEF, about a 40-meter CW transceiver build project that he had done. One of the cool things that we'll talk about is he actually did some, I can't remember if it was laser cutting or CNCing of some custom faceplates for a project enclosure, which is really cool. And as it turns out, Jeff actually is a childhood friend of Kenneth, KWF. Oh, no kidding. Small world.
Yeah, I didn't find that out until afterwards because I think, if I remember correctly, he actually mentioned him in one of the episodes that he did with Kale. So that is one. And then the next one that I recorded is from Rex, KE6MT. And what I loved about Rex's project is it was not inherently ham radio related. What Rex did is he wanted to build a better doorbell.
That's great.
And the thing was, when he sent me information about his project, it was just like Mark. I in the last episode, I'm thinking to myself, this is going to be a 20 or 30 minute conversation, and it turns into something much longer. But we explore so many things. And what I really enjoyed about it was talking about how the way that his mind was approaching solving these problems one at a time. We actually did do a little problem solving together during the conversation. So much like every other listener interview that we've done, I really enjoyed all of these. George, I think you have one in this group as well.
I do. By the way, before we get off on your last interview with Rex, do you know that Rex is a member of our club?
No.
Yeah, Rex is a member of Baynet and some of the other local clubs, and so we've met live and in person. He's a really cool guy.
Well, good. I'm glad to know that I didn't interview any schlubs.
You did not, actually. No. So, hey, Rex, shout out. Glad that we could do the interview with you. Yeah, I interviewed a fellow named Don Corta, KG5IWL, and Don built a BitX transceiver. So the BitX transceivers are super popular QRP transceivers, and we had a chance to chat. The recording was pretty awful because I was in a very echoey conference room when we did the recording, so it's not the best audio. But Don's a great guy. He was very excited about his build project, and one of the things that I really liked about it was he had some ideas about how to package it up, because when you get the BitX, you could put it in whatever box you want. And so he had some ideas of how to mount it with the control surfaces face up like a Manpack. And so the thing I love about it is he didn't have to go out and design the radio, but he had some clever ways to package it. And that's just a whole nother way that you guys can be creative and build your gear. So Don was delightful to chat with, and he was nice enough to make time to do the interview because he was in the process of moving. So he was actually moving states. So by now, I'm sure he's settled into the new QTH, and you'll hear a bit from Don on the BitX transceiver.
Outstanding. Well, let's jump to it after these words from our sponsors.
This episode of The Workbench is brought to you by Autodesk Eagle PCB Design Tools. All of our projects we're doing on the Workbench use Eagle. It's great for schematic capture and board layout. You can easily generate all of the output files necessary to manufacture a circuit board. And whether you're building one board or 100 boards for your friends, use Eagle tools because they have really excellent support. They've got a great library of available components. It's widely used amongst the maker and the professional board design tool industry in general. So you can't go wrong with Eagle. You'll enjoy using the tools, and there's a lot of great new features. Check it out at autodesk.com/Eagle, and you could download a free copy of the PCB design tool today and get started doing your project. Elecraft is also a sponsor of the Workbench podcast. Elecraft is one of my top picks for high-performance HF radios. They make fantastic base station-style radios, amplifiers, pan adapters, and other station accessories. They're also the designers of the KX3 and KX2, the ultimate portable HF radios. If you're thinking about SOTA, portable operating, or travel, you really need to be looking at Elecraft. Elecraft has some of the best designs in the industry, compact, high-performance, feature-rich designs. You're really going to love them. And Cale just got his KX2. So be checking out the Ham Radio 360 podcast and also the Facebook page and see what he's doing with his KX2 radio. The KX2 is my personal favorite for going portable. It's ultra small, 80 through 10 meters, sideband CW and data modes, and the thing runs 10 watts on the internal batteries. You'll love it. Check it out at elecraft.com.
All right, I am joined by Jeff, Kilo 9, Juliet Echo Fox. And Jeff, you have built a 40-meter CW transceiver.
That's exactly right. Yeah, there was a project that was referred to me in a relatively recent issue of QST magazine for a 40-meter transceiver based on essentially modifying one of the numerous inexpensive transceiver kits that are currently coming out of eBay these days and giving it some additional functionality by putting a microcontroller on it. And I somehow missed this article as it floated through the magazine, but it was well within my area of interest, and ended up putting it together and putting it in a box and putting it on the air.
Well, before we jump into that, why don't you tell us a little bit about what style of operating do you do? You know, what interests you in ham radio? How active are you? What are the things you like to operate, et cetera?
A fair question. Yeah. One of the challenges that I face is living in the city of Chicago proper. Getting space outside for an antenna has been a bit of a challenge for me.
Oh, I'm very familiar with that problem.
Right. It seems to be a common theme for many of us. And so portable operating has been a great find. I'll take a small little radio over to a local park and throw a wire in a tree or something like that. And then just in the past couple of months, I actually got my very first 100-watt sort of base station transceiver, and I've been pushing out as much power as I sort of dare to without making the neighbor's lights flicker. So that's been a new experience for me now that I think I have an antenna system that will not fry the local birds too much, as it were.
So what radio did you get?
The base station is an old FT767GX. It's an old Yaesu base station with a vacuum fluorescent display and all kinds of late 80s goodness.
Outstanding.
Yeah.
So before that, did you have a QRP rig that you used?
Yeah. So I was using, at the very start of this journey, I had built a little QRP transceiver crystal-based project that I don't think I ever made any contacts on, but it was a lot of fun to listen to. And then ended up acquiring and fixing an old KD1JV ATS4. It's sort of the ancestor of the modern MTR series of radios. That's a 5N radio, puts out about 2 watts CW, and that was a great toy. But I sort of missed the idea that there were things going on up in the voice and digital part of the bands that, at least if I wasn't set up to talk to yet, would be fun to hear. And that's sort of what led me into building a radio that would at least receive everything within the 40-meter band.
So, you've talked about building radios at least twice now. You've sent us a picture of your Workbench and have a fairly good complement of test equipment. So, you've been a ham, but what is your background with electronics and tinkering?
Sure. Yeah, I very much came to ham radio out of the maker movement. I grew up in Silicon Valley, and though I didn't pursue an engineering degree or anything, the silicon dust is sort of in the air. So I grew up playing with things in the Arduino line or making little LED projects. And now in my present work as a theater technician, which is a line of work in which good and fast and cheap and yesterday are all sort of constant constraints. Using this sort of new wave of microcontroller technology has sort of been a part of our work for many years. And so I found that when I came back to ham radio many years after getting licensed and found that there was a way to incorporate that maker interest into ham radio as a hobby, that's sort of how I found my way in.
That is really cool. That's definitely a nice, diverse background. Of course, I find it funny that here is yet another connection to Silicon Valley. We, between George and a lot of folks that I've been talking to in these series of interviews lately, it seems like everybody goes back to Silicon Valley except me.
Sure. Well, you'll have to get out there sometime. It seems like a real good place.
Yeah. So I keep getting told. So talk to us about then this 40-meter transceiver. Tell us what are the specs of it?
Sure. So in its essence, it's a 40-meter direct conversion receiver with a pretty minimal amount of filtering. And if I were to do it all again, I would probably beef that up a little bit. But essentially, the RF comes into the receiver, goes through a little low-pass filter, goes straight into a classic NE602 mixer, a little 8-pin mixer chip that's being driven by an AD9850 DDS frequency synthesizer chip controlled by a little Arduino Nano, I want to say. I always forget which brand it is. Pro Micro, maybe. And that directly converts the RF down from the desired frequency to audio. There's a little bit of audio frequency filtering, and then the audio is piped straight out the headphone port out the front. So it really isn't a very complicated device. The sort of guts of the project center around the Arduino programming, which really is just being used to control the digital frequency synthesizer. But because you've got a microcontroller built in as the brains of the thing, it's really easy to add new features or add a display or change the control mechanism. And so that's been a really fun part of the project. Now that I have a working transceiver, to sort of play with what flexibility having a microcontroller built into the heart of it gives me.
So now one of the things is that you shared with us is you did a really good write-up on your website for this, which of course I will include in the show notes. But when I'm looking at the pictures, it looks like you started off with a kit.
Mm-hmm. Very much so. Yeah, the guts of it are based around this little $8 audio kit, which you can find on eBay, I'm sure still to this day. They call it a 49er, and it's sort of they ripped the name off of a classic design of direct conversion transceivers from the mid-90s. It doesn't bear that much relationship to the original circuit, other than that it's direct conversion. But yeah, the guts of it are a little $8 kit, comes with connectors, comes with a little bit of interconnect wire. And the Arduino and the frequency controller are mounted on another kit board sold by a kit maker at the time. And so it was dead simple to assemble and was really a great platform to expand from there.
Oh, that's really cool. Yeah, as I scroll down, I see there's a very nice clean board design that have the Arduino and the DDS module on it. And it looks to be about the same size as the original component. So you had mentioned this had come from a QST article.
Mm-hmm. Yeah, so there was an article, and I'm going to forget the month, so forgive me, but there was a QST article by an author who essentially proposed, there is a flood of these inexpensive radio kits coming across the internet now, but on their own, they're not all that flexible. This particular kit is meant to be rock-bound, so you'd have one frequency forever, and if someone's not on that frequency, you're out of luck. And the essential point of this article was, what can we do to, in an inexpensive way, it's silly to spend $200 making an $8 radio kit better, but what could we do to give this a little bit of flexibility? And that's essentially where that started out.
So some of the things is you had mentioned that there were certain modifications that you had made. For instance, the original project, I think, had like a 16 by 2 LCD.
Yeah, so the original Arduino code called for a little basic LED LCD module for frequency display and also for letting you know whether you were in the appropriate part of the band or something like that. And as I proposed to take this portable and was looking at battery draw, I really didn't want to be spending the 100 milliamps, 150 milliamps for a really nice bright LCD backlit display. So in preference to that, I went in and stripped all the code out that was supposed to be driving the LCD display. And now the module, when you press a little red button on the face panel, just blinks the current frequency at you on a little panel-mounted LED in Morse code. And since it's only on 40 meters, I usually don't have it tell me that I'm on the 7 megahertz band. I usually just have it start with the kilohertz. But I found that to be a really easy and low power way of sort of getting a frequency readout in there.
Yeah, that's really clever in order to minimize your power consumption and something that, like you said, is dead simple. Now, did you write the code for that yourself, or did you use a library that existed?
The code for the frequency readout I just wrote myself, which was relatively straightforward. You teach it what the 10 digits are, and you teach it to transmit. It turns out, having an Arduino transmit Morse code or key an LED to send Morse code is dead simple. I wouldn't want to try and receive Morse code on it, but that code was pretty straightforward.
Now, you had mentioned that there was no filtering, and that if you had it to do over again, that you would include some RF filtering. Talk a little bit about what you would do.
So one of the problems, and I'm sure this is universal, but especially living, about 4 miles from a bunch of AM transmitters in downtown Chicago, the broadcast interference at my QTH is really extreme. And any radio that doesn't have a really beefy amount of filtering, I just end up listening to NPR all day long over a CW conversation or something like that, which makes it a little bit tricky. So what I would probably do, and probably should do, is just incorporate a stronger bandpass filter into the front of the module. It currently, if memory serves, has something like a little 3-component, a couple of capacitors, and a little RF choke to form its basic low-pass filter circuit, and that's all the filtering it has. And even beefing that up to a 5-pole or a 7-pole filter with some common components, I think would help. I've had some luck with that on projects before. The other thing about it is because it's an NE602 based project, the NE602, which is somewhat maligned, but is a great, easy to work with part. But one of the things that is true is that it overloads very easily. You start, getting gain compression at very, very low power levels. So even with a significant amount of filtering, if that AM is still in the background, it makes it hard to hear what you're supposed to be listening to. Not only from I'm having to listen to Peter Sagal over the voice of my conversation, but also there's actually reduced gain on the signal I'm supposed to be receiving. But a simple 7-pole filter with 4 capacitors and 3 little chokes soldered together would probably knock it down enough to make it workable.
So another question that I have is, it was a project board, or a couple of project boards that you had gotten for this. At the end of the day, you're trying to build a radio that you're going to take out in the field and actually use. And, I spoke with somebody yesterday who had built a project, and it was still on a breadboard with a lot of loose wires, and that's not conducive to being portable. Mm-hmm. So how did you ultimately package this thing up?
So the packaging is in 2 parts. The main body of it is actually an upcycled container from an old VGA to component switcher that I found at a computer supply store. A simple black sort of clamshell case that snaps together. And what I found fortuitously is that 2 standard power poles stacked side by side will just fit through the hole that a VGA connector was supposed to fit through.
Well, I'm going to have to file that away.
Yeah, it's really handy. So that's the power connection I didn't have to do anything for. And because it was component originally, a BNC connector is meant to fit through the holes in the back. So I didn't have to do a whole lot of mechanical work to get the connectors out, which is something that I always, as a homemaker, stress about is, the tolerance on my little handheld drill gun is not so good that I might be able to align components right. So when it came to do the front of the board, I actually went down to our local makerspace and got a piece of a clear plexi laser cut, just so that I knew that the spacing for all the critical connectors on the boards themselves were going to be accurate.
Well, so that's another thing that's I found interesting, is that you actually tried to do the panel work, because I don't know if you've ever seen my YouTube channel where I've tried to, there's this power module that I designed a long time ago, but I've never actually built. I get angry emails once a week. When are you going to do the third video about building this thing? And I'd stuck it in a Pelican case with a panel mount inside. Never actually got around to designing or making the panel. And part of the thing that I was afraid of is, tolerances and corner radiuses and the fact that I was going to have to make 6 of them before I got it right. So talk about the process of actually making that. Because, that's something that folks probably don't have access necessarily to the tooling to do in your house. But it is something that's a handy skill to have. Like, talk about the design and then how you actually made it.
Certainly, yeah. So one of the hardest parts I think of any mechanical design, especially when you're basing it on somebody else's pre-built modules. If this was something, a circuit board that I had whipped up from scratch and I got to set all the dimensions myself, then I would, already have the CAD files or the Gerber files or what have you. But building it on somebody else's module, it sort of comes down to how good a set of calipers can you put on a thing to make sure you're getting accurate measurements, and then just being prepared to do 2 or 3 or 4, rough drafts of it to make sure you get the spacing right. But once the measurements are down, it was really a pretty simple process of laying out the faceplate in CAD software. I use Vectorworks as my package of choice, but AutoCAD or even SketchUp or any of the basic layout packages will work just fine for panel work, I think. And then I took the panel to our local, our downtown library here in Chicago actually has a couple of laser cutters in it, which is, boy, a great resource to have nearby. But there are services now, I think, that will, if you send away your panel to, will gladly cut them for you. And then it was just a matter of selecting the appropriate material to fit within the existing walls of the case, and actually doing, like you say, doing the corner radiusing and making sure the tolerances around the edge of the case were correct actually turned out to be harder than getting the component, the connector spacing on the front of the package there correct.
How many iterations did you go through?
I think we went through 3 iterations after we got the laser cutter working right, and I think 2 before that. So I have 2 panels which have no holes cut in them at all, just lightly scored lines, and then 2 rough draft panels, and then a final one that actually works. Which, 5 designs for, a little tiny face panel, only cost me $3 or $4. So I think it's totally worth it.
Yeah, and 5 seems like a good number. When I've done, whenever I've actually tried prototyping boxes or cases or things for, there's it's a D-Star and DMR hotspot board called the DV Mega. Lots of people had designed cases, and they either sold them. Actually, I didn't see anybody who released an STL of the file or of the design open source, and all of theirs were like 2 clamshells with a screw in the middle. And I said, well, I'll do something simpler where I just made a box. You slide the 2 boards in, attaching the antenna makes it captive inside the box, and then there's a sliding door, and then attaching the USB cable to power it makes the door captive. So I designed that, but I ended up going through 5 or 6 print iterations before everything fit. And it would be print, get the calipers out, measure, go make adjustments to the model, reprint, et cetera. But I
always go on.
I'm going to say personally, though, that prototyping is really satisfying to me.
Yeah, there's something about taking not only the electrical design, but the actual physical product you can hold in your hands from conception all the way to having a thing you can throw in your backpack that's really fun.
So I take it you have actually made contact on this?
I have. It's tough. It's tough. And like any direct conversion receiver, it has the problem that it receives signals on both sides of 0 beat. So, if there's a signal at let's say my VFO, if I'm tuned to 7.030 megahertz, a signal at 7.032 and a signal at 7.028 sound the same in my ears. And so I'm in this conundrum whenever I take the radio out. Am I hoping for a busy band with lots of people I might be able to talk to, but it might be hard to tell who's talking back? Am I hoping for a sparse band with somebody who I might not be able to find anybody who can hear my little 3 watts of signal, but if I do, they're all mine for the taking. So I haven't yet made a contact from my home base actually with this. I've only used it portable. But yeah, I think best DX with this is probably North Carolina. So 1,000 miles on 3.5 watts is not bad.
No, that's not bad at all. Now, you kind of implied earlier, if I understood, well, maybe you didn't imply, you may have said this, but if I understood earlier, this was not your first radio that you've built, and I'm assuming it won't be your last.
No, definitely not. I will say the next project that's on my bench, this project was a very digitally oriented project, and there's a lot of strength, I think, to incorporating microcontrollers and programming into the development environment. So my next project, I'm going sort of hard the other way and doing an all analog double sideband radio with an analog VFO and things like that. And there's a lot of gotchas when you move back into the analog domain from the digital domain, I'm finding. But that's part of the fun of it, I think.
What's one of the biggest gotchas you found?
Right now, the two problems with that particular transceiver, one is, as I think I mentioned earlier, I blew up the transmit receive relay on it, which was unfortunate. So that would be a bit of a problem. The other gotcha, though, is the effect, the proximity effect of the various components is very striking. And by that I mean it makes a big difference which way you route your wires between the various parts of the board. When I connected, say, the mixer to the VFO, my VFO tuning dropped about 5 kilohertz just by adding a little bit of wire to it, which in a digital system, more than anything, it's plug and play. And this is got a lot of, placement matters, positioning matters, and keeping lead length short matters. So that's been kind of an adventure, but a fun one to be sure.
Well, cool. Now, one of the other things that you had shared with us, which I was particularly interested in, is that you have some experience building the K3NG CW machine that is basically, we've talked about it before, it's an Arduino-based CW project that the firmware is like infinitely expandable. You have to go in and customize which modules you want to include or not include because the standard Uno doesn't have enough memory for everything. Mm-hmm. So
yeah.
You've built one of those?
I have, yeah. I have a little, based on the little Arduino Micro, it's just sitting in a little quad box on my desk here. And like you say, the customizability of that firmware is fantastic. I mean, you can choose to include iambic keying or not, or have it be an interpreter for your computer's CW generation commands. It could be a code practice oscillator. Yeah, and that was a lot of fun. And actually, that was a great project to do because so much of the functionality is built into the firmware. That really became a project about how to solve the packaging problem. Because I didn't want a 12-inch by 12-inch box sitting on my desk just to be a CW keyer. I needed something a little bit more compact. And I think we got it down to like 3 inches by 5 inches, and that was a lot of fun.
So one of the things that, when you were talking about the 40-meter transceiver with the DDS module in it, have you considered the opportunity of actually trying to put the K3NG keyer inside of it?
I never have, but it wouldn't be at all hard to do. And certainly that's a really good thought. You could even run, a subsection of the K3NG code on the same Arduino that's currently driving the system without too much extra work. One thing I played around with for a little while was trying to build a little Whisper transceiver out of the same kit, because Whisper and like JT65 or JT9 is a single tone transmitted at any given time, and so there's no reason why a CW transceiver with an oscillator that you can control through a microcontroller can't just generate those tones on the fly. It'd be your digital transceiver as it was. And the downfall of that project ended up being to redo the keying circuit to get it to turn itself on and off. Proved to be a little bit harder than I was willing to take on at that point.
Yeah, that was one of the other things I was going to ask is because if you go to the page and you look at it, there's the firmware and that's all well and fine, but then there are also several schematics available for actually hooking the thing up so it will interface with radios or interface with keys and whatnot. Mm-hmm. So I was going to ask, did you actually source the parts yourself, or did you buy one of the pre-made kits that either used to be or may still be available?
Yeah, sure. And there are, I think there's a few that are still floating around out there. I happened to have most of the parts in my junk box already. The sort of critical parts are the Arduino itself, a handful of basic NPN transistors, a 2N3904, a 2N2222, some basic resistor values. I think there's some like 100 ohm and 1K resistors in it, and then and then a handful of buttons. As many buttons as you feel like you can actually squeeze onto your case, the firmware will take into account. The only part of it I think I had to source was I needed a new voltage regulator for the system. I didn't want to power it all off the Arduino. And for things like that, either DigiKey or Mouse are great sources. I sort of shied away from some of the other let's say cheaper but less reliable sources for a little bit of that part sourcing, just because I've had a little bit of bad luck with I couldn't either counterfeit parts or defective parts in the past. So for a 50-cent regulator, I just go through DigiKey these days.
Oh, absolutely. Now, when your Arduino and the DDS module, where did you source those? Did you buy them on eBay from a Far East supplier?
That's a fair question. The Arduino came from Amazon, so I couldn't actually tell you geographically where it came from. The DDS module did come from overseas, and so far it's worked just fine. It's been very reliable. So for those purchases, I did end up going with a digital supplier from across the ocean, as it were. So
besides DigiKey, Mouser, and the common big parts houses, are there any other places that you tend to source components from, or do you ever bother scavenging them out of the dumpster, or?
That's a fair question. When I was very first getting into radio, I spent a lot of my time pulling components out of old broadcast, receive radios, which was great. I learned a ton about how you put a product together, or how you inexpensively put a product together. These days, I find that by the time you've wrangled a transistor or something out of a production product, once you've salvaged it, either the leads are bent or you fried the component with too much heat or something like that. So I typically end up sourcing them direct. The one component that I will still, grab a dollar store radio and pull a component out of is a variable capacitor. All of the radios I have pulled apart pretty much have the same, 300 picofarads plastic box, about an inch square variable capacitor in them. And I've used those for a number of projects just because they're, for some reason, very, very expensive to buy new. But all of the production radios I've pulled apart have them. So they must have a source that I don't. So I'm happy to yank a radio apart just to get them out.
Well, Jeff, I want to thank you very much for coming on to talk about your radio and a little bit about the K3 and G keyer and sharing. I always am very humbled when I speak to people who build their own radios, because I don't know if you heard when I told George that he was a wizard and I was Squib, but when I talk to somebody who's built their own radio, that technically makes you a Jedi.
Well, if I was, maybe I could tell when a fuse is going to blow before it did.
So, but before we part, are there any tips or tricks that you would share with Workbench listeners about, I don't know, techniques or shortcuts or mindsets or perseverance?
Yeah, I would say one of the tips I would share is that getting into homebrewing radios is really not, I think, as difficult or as expensive as some people think it may need to be. I mean, certainly, I think I mentioned earlier, there are lots of things that can trip you up and that you have to troubleshoot and problem solve, which is part of the joy. But for a basic set of equipment that you can do homebrewing with, which really, to my mind, if you have a half decent soldering iron and an oscilloscope that doesn't have vacuum tubes in it, or maybe even one that does, you can pretty much start homebrewing something right away. There will certainly always be challenges. There will be faulty components. There will be tracks that get bridged. That's one thing that I learned on this next analog project is, after whacking a great big blob of solder onto a board, sometimes things are connected that shouldn't be, and that can be problematic. But it really is not too scary of a thing to get into. I will say, if on a tip sort of level, having a decent soldering iron makes all the difference in the world. I thought for years and years that I was really bad at soldering, and it turns out I wasn't bad at soldering. I was really bad at buying soldering irons.
I had the exact same experience. Until I got my Hako, I learned that I had been soldering with bad equipment and doing it wrong my entire life.
Yeah, it's really true. And the wonderful thing about today is I also have a Hako and I love it a lot. But, at work we have a Weller that works great, and even something like a Tenma variable temperature pen, something more than a 15-watt Radio Shack iron with a decent tip that you can keep clean. That's just the greatest present in the world.
Well, awesome. Well, Jeff, thank you so much for spending your time with us and sharing with our listeners. Keep in touch. Please let us know about the next radios you're building. I'm sure that we're going to do another one of these in the future, and we'd love to check back in.
Sounds good. We'll keep you posted, Jeremy. Thank you so much.
All right. Thank you.
So our next listener that we're going to talk with is Don Coda, Kilo Golf 5, India Whiskey Lima. And Don is from Louisiana and just about to move to Oklahoma. So Don, thanks for taking a few minutes to chat with us today.
Not a problem, George. Thank you.
And you're working on a project that caught my eye because I've been following this design of a radio for some time, and I haven't built one myself, but it sounds really interesting. So before we dive into that, maybe could you give us a little bit of background about Don, a little bit of your radio background and the kind of things you're interested in?
Sure. Well, first of all, I'm retired Air Force, did 20 years active duty, and then came down here to Louisiana to be with my wife so she could finish out her 20 years. I've been in the ham radio hobby for about a year and a half now, give or take, and really kind of jumped into it full swing once I got into doing the hobby there. Got together with a great Elmer, Carl, KB5WMY, also here in Bossier City, Louisiana, and he's been helping me along the way, building antennas, 2-meter single sideband, Skywarn, Aries, you name it. I've kind of dove into the entire program.
Oh, that's great. So has most of your activity been VHF then, as opposed to HF?
No, actually, I've done VHF, HF, PSK31, JT65. I've dabbled in a little bit of everything.
So that's quite a bit of different subjects. And so I guess one of those areas that came up is HF and maybe HFQRP, which is the theme of the project that you're working on. So why don't you tell us a little bit about the project at a high level, and then we can go into some details.
Sure, not a problem. Well, I am very much interested in going camping and being able to take HF with me. Field day was a blast for me. The BitX40 is a 40-meter single sideband voice kit created by Ashar Farhan, Victor Uniform 2 Echo Sierra Echo. And it was just something I wanted to try. There's a plenty of CW Pixie kits and stuff like that out there, but there wasn't really any sideband kits until this one came out. And when I saw that, I was anxious to give it a try.
So what are some of the top-level specs of that kit?
Well, it's first and foremost is they designed it so that you could add on to it. They want you to take their kit and make it better, whether it be adding an amplifier, adding a better power supply, adding different chips. You can. I've seen one person who's been trying to add multiple bands to it. There's just a lot of different aspects of it that you can do, and that was his biggest deal. Is he wanted people to adjust it and fix it to fit their needs.
So I understand it's a 10-watt single sideband only transceiver, correct?
Yes, sir. Actually, I believe it's 7 watt, if I'm not mistaken.
Okay, 7 watts, but no CW, right? Strictly sideband?
Strictly sideband. You could probably rig it to hook up a keyer to it. I haven't seen anybody, nor have I looked for anybody that was trying to do so.
So when you looked at this as a kit, what were you planning to do? Was it more just the fun of building something, or how are you planning to use it?
I like to build radios, either rebuild them or build them from scratch, whichever the case may be. I've been trying to hone my soldering skills. I do have to say that a majority of this kit already comes pre-assembled, as most of the parts are surface mount, which isn't in and of itself a problem. Takes a little work off of myself, but definitely, it's really quick to put it together. I think it took about 45 minutes to put the whole thing together. And that's just the basic bare bones part. That's not including mounting it into a case or anything like that.
So the circuit board is largely assembled, or is it completely assembled?
It is not completely assembled. They left a few parts off, easy parts. You got to attach your own antenna connector, SO239, PL259. I believe it actually comes with a BNC connector, if I'm not mistaken. You have to connect the tuning and the volume control up on there. and your push to talk and your microphone and speaker.
Okay, so really the external wiring you have to do yourself.
That's correct.
So is there a case for that? I think I saw some pictures where you're doing a custom case, right?
I'm building a custom case together with another ham friend of mine here. He has the CNC machine and I have the ideas. There's several that you can actually buy online, but there's just nothing that really pops to me, so I wanted to build it my own way.
So what's your case going to be like?
I plan on making it a mostly metal body, obvious reasons to help with grounding, but I'm going to make it mostly a metal body, and I want to go ahead and make it where the display is right in the center. You've got your knobs off to either side. I don't like the PTT switch that they came with, so I'm going to go ahead and actually rig up a microphone to it and add a better speaker to it than what came with it.
So on yours, the front panel, there's a display for the frequency for the radio, I believe.
There is, yes, sir. Right now, it's only set for just the frequency display. There are some codes that you can put in, and if you're up with Arduino at all, I'm not too great with that yet, but you can actually add an S meter to it and a bunch of other things that'll display it, whether it's upper or lower sideband and so on and so forth.
So the software that's running the radio, being an Arduino code, then do they give you the source code, I guess, so you can modify it?
Yes, they do. You can actually go to their website and download the source code. Also, I'll encourage, too, that anybody that buys the kit should definitely look into the groups, the Yahoo groups or the groups.io website and join them, because not only do you have a lot of different hams that are building it with a lot of different ideas, but it has all the downloads that you could possibly want for this radio kit.
Oh, that's a great idea. I was curious, when you're thinking about the box, the traditional box approach is to put the controls and the display on the end. And there's a lot of trail-friendly radios where they've moved the front panel of the radio to the big flat surface on the top, so you can set the radio down. Did you think about that too, or is that just not the way you would have done it?
Well, here's the way I'm looking at doing it is I like to put things in a backpack or a little case or something to that effect, something that makes it easy for me to carry. So I plan on actually bringing the antenna connector, the knobs, and the display all right up on the front of the radio, kind of like a standard setup, except for the antenna connector there. Bring it all up to the front so I can put it in a little type backpack and carry it around with me and be able to power it and just go right from there.
So that's going to be like a man pack, a baby man pack configuration.
Exactly.
It'll be the PRC 0.74. So you just need a big G.I. Joe whip antenna coming out the top. You'll be all set.
That's right. A big PRC 74 antenna on top, and you're good to go with a little 5-inch squared radio kit.
Oh, that'd be great. So when you built the kit, was there much to do in terms of like aligning it or tuning it up, or did it pretty much just kind of hook up and plug and play?
For the most part, it's plug and play. I did notice that it did take a little bit of tuning and tweaking on the tuning pot to get the frequency to line up just right. But for the most part, I mean, it was pretty much spot on.
And is it? It's 40 meters, right? The version you built?
Yes, it is. It is 40 meters.
Do they come in different band models?
They do have a 20-meter kit, but you have to contact him, the owner, Ashar, directly with an email, and he'll send out one to you with a different price quote. And also, there are mods being done right now to make it a multi-band 4 or 5-band kit.
Oh, very nice. Very nice. Because actually 7 watts is, well, that's not a lot of power, but when you look at a lot of the other QRP radios, some of them, like the 817 for single sideband, is 5 watts, maybe a bit less. So 7 watts, not so bad. But, when you're doing SOTA operating, you're up on top of a hill somewhere, then that QRP may be okay, maybe enough to make a contact even with these lousy band conditions.
Oh, exactly. And the one thing I like about it is they actually leave a spot open for you to mount an amplifier on it, an inline amplifier, to go up to 15 watts. I apologize, 30 watts. So that's a big jump. A lot of the QRP radios, you have to add a special amp to get it to do that. That's pretty good.
Did they make an amplifier board for that, or is that just for someone else to do later?
They don't make an amp for it, but there are several of them available on eBay and Amazon.
Oh, no kidding.
Various different sellers have them on there. They're kit form. You build the amplifier up when you get it, and then just hook it up from there.
So when you powered it up and used it for the first time, what was the experience like?
Well, at first I didn't think I was going to get anything on the radio. I wasn't hearing anything for whatever reason. I went ahead and hooked up a different antenna onto it. Come to find out, that was my problem. I didn't have a good enough antenna on there. Threw on a better antenna on there. I believe I hooked it up to a dipole, and as soon as I tuned around a little bit, all of a sudden there was signals coming in left and right. I think I heard about a total of 5 QSOs and participated in one.
Oh, very good. So the first time out, you're able to make a QSO.
Yes, sir. And my RST, I asked him for a honest RST there, and he gave me back a 5.7, which I'll take that.
Wow, that's excellent. That's really pretty good.
Agreed.
So what did you use for a battery?
I used a little, 7 amp hour, 12 volt battery, basically a little backups battery, and hooked it on directly to the board with a fuse in line, just, make sure I didn't blow anything. And I also added a protection diode as well.
So that's something that you can find at any decent battery electronics store. So those are really common batteries.
Yes, sir.
Yeah. So one thing that really shocked me when I saw these radios was the price. How much was the radio when you bought it?
I initially paid $49. I actually got the kit before it came with the display. Literally, I ordered it a week before they put the display on with it. So I emailed the creator there and asked him if there was something I could do, or if I needed to replace the whole kit. And he just asked me to send him $15 more, and he'd send me out the display board and all the components. So a total of $59. That's not a bad price for a 40-meter radio.
Boy, no kidding. $60 for a pretty much assembled radio for the most part. That's amazing. So, one thing I really love about this kind of a project is a lot of people would love to build a radio, but they don't have the time or maybe the experience to go through the trouble of assembling something with that many components. I'm not sure how many parts are on the board, but it's probably 50 parts or more, I would think. And, you look at that and think, well, that's a couple weekends, or I'm just not going to get to it. But when you can get the radio board by itself and it's pretty much assembled, and then your creativity shifts over to the packaging. And I think for a lot of us, having a functioning radio and then using our creativity around, well, how would we package it? Like your example, where you're going to look at bringing all the stuff up to the front. Someone else may bring the display to the top, or maybe you'll build it like a conventional radio, or maybe you'll modify it. And I love to see what people are going to do with these things.
Well, YouTube is the best place to check out and get some different ideas. I'll be the first to admit that. What I liked most about the instructions that came with this, most instructions, as you know, are very difficult to read and lost in translation. These are really simple instructions. You get them in, you open it up. If you've only got 5 or 10 minutes to work on it, you do as much as you can, and then pick it back up later, and you won't even forget where you left off. It's right there, ready for you to go again.
So it sounds like a great kit. We were actually thinking about this as a potential group build project further down the line, even though it's not something we designed or would provide. But we were thinking this might be a nice topic for people to go out, buy the kit, and then build them up and get the experience of using them. And since you can modify it both in the hardware and also in the firmware, see where people are going to take it. Like you said, look at the YouTube videos and the websites and so forth, and see where the crowd goes. Because for $60, I mean, it's hard to beat that.
If you can beat it, you let me know, and I'll buy a bunch of them.
Well, Farhan has done a fabulous job. I heard about him first from Bill Mira's Solder Smoke podcast, and they've mentioned him many times. And so I looked into it after. I think Bill built a BitX, maybe a 20-meter model. And that's what first got me interested. And then when I saw it, I thought, wow, this is really looks pretty cool for a very reasonable price. And then seeing your post there, I really wanted to follow up with you. So is there anything else that you would share with our listeners about the radio? Any advice?
I will say that if you're going to order one, get in contact with them as soon as you possibly can. It does take about 3 to 4 weeks to get it from India, where he's at. still, that's really good time. And I will also mention, too, that if you have any issues with it, he contacts you via PayPal whenever you complete the order, and that's where he'll send you the shipping information and the tracking information, so on and so forth. And if you have any issues, he is really quick to contact you back and respond to you so that you feel comfortable with your order. If something doesn't arrive with it, he's ready to make it right for you. That's good business for me, so it's worth a little bit of extra weight there. All I say is get your boards out when you get them, and don't just stop at the kit. Modify it, make it more, make it better, make it for what you want it to be.
Oh, that's really great advice, Don. Well, hey, I want to really thank you a lot for participating on the podcast and for letting us chat with you a bit about the project. So after this is over, do you have another project in the queue that you'd like to work on?
Just moving for the moment.
Well, I wish you all the best in the new QTH, and thanks a lot for being a listener and for spending some time with us on the podcast.
Thank you, George. I appreciate it. It's been a blast.
73s, Don.
7-3s.
I am with Rex KE6MT, and Rex's project was very interesting to me because it had little or nothing to do with amateur radio. Rex was trying to build a better doorbell.
Yep.
Which sounds incredibly exciting, and I can't wait to get into it. Rex, how are you this evening?
Not too bad. We're enjoying the evening over here at my friend's, having a little Oscars party.
Outstanding. So, give us a little bit of background about your history with amateur radio. What do you like to do? How do you like to operate, etc.?
Yeah, so it's I'll try to make it as short as possible, but there have been a lot of facets for me. But what it boils down to is I really loved to be in touch in some way when I was in the backwoods, in the outdoors, roaming around, doing backpacking, the sort of things I like to do. I had one of my FRS radios die on me. I was in the middle of a run from one place to another in Yosemite Valley in the middle of a thunderstorm, and I had one of my FRS radios die on me, and went to look for another radio, and I saw one of the Baofeng or Baofeng, however you want to pronounce it, radios on Amazon, and I said, "Oh, what do I need to do to use one of those? It seems like it's not, your typical FRS radio." And I said, "Oh, okay, I have to get a ham license." And I looked into that, and I said, "Oh, they don't require code anymore." So I just went full speed ahead on getting that, and just dove in head first. I got the handheld, the walkie, handy talkie, and it evolved from there. But it's still outdoor operation, portable operation is my favorite method. I've evolved to operating on HF because that works anywhere, and that's pretty much my story. I love operating in the outdoors, and I love all of the technical aspects of ham radio.
So out of curiosity, what is the HF rig you take to the field?
Well, so the one I have is the FT817, the ND version, the newer version, and there isn't much of a difference between that and the older one, but that's the one I have, and I love it. It's a great radio. It operates on all the bands that you would care about, but I would really love to have George's KX2.
I know where you can get that.
I had my hands on it.
Well, awesome. All right. Well, it's good to know that Kale is in good company as far as, so there's KX2 for Kale, and then we'll do KX2 for Rex.
Exactly. We need to create that hashtag.
So, a better doorbell. Yes.
So this occurred around the same time as my entry into ham radio. And it's interesting because I work in web development. I build websites for a living, and I'm always thinking with how do I solve this problem better, or how do I solve it in a new way, that sort of thing. But ham radio got me into the mind space where I'm thinking with things from an electronic perspective as well as code, because that's what I do. And the origin of this doorbell project is interesting because I wanted something that wouldn't make my dog bark and wake up my kids when somebody rang the doorbell.
As a parent with 2 young kids, I can completely respect that thinking.
Exactly. They're 8 and 5 now, and I don't really care so much because they won't wake up once they're asleep. But my dog barks no matter what. If there's a doorbell sound, a knocking sound, she'll bark and wake people up. And so that was the origination of the project. And I was thinking with RF and electronics because of the ham radio studying I was doing to get my ham license, and I was doing all of this around the same time. And so what this doorbell project does is very simple, and there's products you can buy now that do things way more advanced than this, but all it does is you push the button, you push the button and you get a text that your doorbell has been rung. And hopefully you have your phone on you.
So talk us through what are the components involved in going from the cheap plastic little button on the front of my house to getting a message on my iPhone?
Yes. So originally I was hoping to take advantage of the wireless doorbell button and receiver combination that had been at my house when it was there. And, if you're into solving problems, you always try to solve it as simply as possible, unless you're trying to really learn a lot about the subject. And sometimes you're forced into learning a lot about the subject, which is the case with me because I couldn't find the receiver for my existing wireless doorbell.
Minor problem.
Yeah. So originally I was going to take the existing wireless doorbell, hook it up to my Raspberry Pi, and trigger one of the digital input pins on there. And the rest would be programming, which I'm familiar with, and go from there. But that was not the case. So I had to build my own doorbell transmitter, and I had to build my own receiver. And I always, not always, but often try to do things as cheaply as possible. So
that's a pretty common ham trait.
Yeah, it is. Yeah. So, I heard the podcast with you guys. I think it was one or two podcasts ago. You guys were talking about, maybe it was just one Workbench ago. You guys were talking about different RF links and simplicity, and George is all about getting something that just works basically, and I really appreciate that because I went through a whole different journey. So now I'll talk about the components that I put into this. I got the cheap eBay special, simple, stupid, or dumb. We'll use the word dumb on this. Dumb transmitter receiver combo. The transmitter's a tiny little transmitter, transmits on one frequency, doesn't have any native two-way. It's not a transceiver. It doesn't transmit and receive, so it just transmits a signal. And I think I got the 433 megahertz one. And I was all excited at the time, too, because I was like, I have my ham radio license now. I had just gotten it a month before that. I have my ham radio license now, so I don't have to worry about which frequency I get this device on. And I've since learned that I should care. But so I got the transmitter receiver combo for like $1 off of eBay or something like that.
That was probably $1 shipped.
yeah, $1 shipped. You just have to be patient, and I got that and started looking into ways I can actually send data across that transmitter receiver combo, and kind of dove into, you take these projects in chunks. So I solved that data communication problem first. That was kind of the first phase of this whole thing. How do I get a signal from the doorbell button to my receiver and know that it's my doorbell button and not something else? because with these super cheap eBay special transmitters, and I don't know, we can throw a model number out there, but it could be wrong. It's an FS1000A. You have to do all the work with that RF connection, like George was talking about. You have to actually take that RF link and do things to get your digital information across that link. And in this case, I used the I don't know if you want me to get into what Arduino libs I used in order to accomplish the communication.
Well, so let me ask a couple clarifying questions.
Yeah.
So I'm assuming on the doorbell side, obviously it starts with a button that you probably picked up at Lower Home Depot.
The button. Yes. So let's take a step back there. So I had to trash the idea of using my existing wireless doorbell. So I went on a search for buttons that would work well, and I thought I had the right button. I had this nice red push button from, I think I went to one of the local electronics parts suppliers just looking at buttons. And I picked that button out, had it all picked out, and then when I ended up putting the final product together, it didn't fit. The circuit board didn't fit into the project box that I had made for the doorbell. It was really small.
Minor detail.
Yep, minor detail. So I ended up going with a one of those generic micro switches that it's the push button not surface mount, but
yeah, the one the legs. I mean, they look like they're small enough they could be SMT, but it's basically I don't know, maybe like a centimeter and a half, and it's got a little black button, 4 legs. Yep.
Exactly.
Actually, they're the same buttons we used on the antenna analyzer kit.
Yes, those exactly. Yes. So I took one of those and mounted that on the circuit board, and I took apart the button that I had picked for this project. I took that apart, and I used the actual plastic part of the switch to push the micro switch on the board that I had put together.
Gotcha. So you have a board with a switch, and did you have an Arduino at the button side?
Yes.
What did you have?
So that's an Arduino Pro Mini. And that is an Arduino without the USB interface, basically brought down to as small as it can be. The Arduino used on the antenna analyzer is actually about the same size and has the USB interface. But I either didn't know about that at the time or was concerned with power consumption, which we could also get into that aspect of things.
Well, actually, that's another question. So at this point, you've got a custom board that you've done?
This is one of those prototyping boards with holes on it.
All right. You've got and then you've got a box you've got it mounted on the outside of your house. Is the Arduino in that box as well?
The Arduino is in that box.
All right. So then, let's talk about powering, because right now there's a couple of pair of wires running to my wired doorbell that keeps the little incandescent bulb going, so you can find the doorbell in the dark. Since you said you had a wireless set before, that implies to me that whatever that line was probably not available to you.
Correct. Yeah. So we have a house built in the late 40s, and it probably had a wired doorbell, which was removed at some point for unknown reasons, probably to make this project challenging for me. So I had to solve having an Arduino on the transmitting side. And mind you, looking back on this, I realized there's many simplifications that could have occurred to make this easier on me. But I don't know. Sometimes, when you think you're innovating, or maybe you are innovating, you want to do the thing that may be harder. So,
it certainly builds character.
Exactly. So I have an Arduino on the transmitting side, a little RF module on the transmitting side, and our button. And I think that's it on the transmitting side. Yes. And I have all of this in a little pretty small project box that's just a tiny bit bigger than your typical doorbell button. No lighted switch, by the way, which, as you mentioned, it'd be nice to be able to find it in the dark.
I don't know. Because if you're like me, people that ring the doorbell are strangers.
Yeah.
And so
true.
You don't want people ringing your doorbell at night.
That is very true. And we have a motion sensing light, so it comes on, you can find it. And by the way, this box is black with a red button on it. So I'll get to that point a little bit later. But my wife didn't like the fact that it looked like a detonator for a bomb. I ended up painting it. So we have an Arduino Pro Mini on the transmitting side and a little RF module and a button. And so I had to solve the RF aspect of this. And so I got into the whole Arduino software end of things and used a lib that does RF communication. So it takes care of all of the whatever you're going to do there. You want me to describe the hardware first and then dive into the software end of things?
You tell the story however makes sense. I mean, and I'll help you along. Just since you mentioned it, what library did you use?
So I used, I love the name of this library. It's Radiohead.
Nice.
I like the group and most of their stuff anyway. And it's kind of a catchy name. So the library takes care of whatever modulation you want to use and whatever modulation the RF module can handle. I ended up going with amplitude shift keying, which is a fancy way of saying it's very, as far as I know, it's very, very similar to on-off keying or Morse code or whatever zeros and ones over the air.
Gotcha.
So I ended up using that lib to do the RF communication. So the hardware, so we have an Arduino Pro Mini on the transmitting side. We have the RF module. And I had to somehow power all of this. And I looked at a lot of different ways of doing that. I thought of running power out there because an Arduino burns through, I think it's when it's idling, it's at least 50 milliamps or maybe 90. I'm not sure what that number was. But whatever it was way too much to just run it on a battery. I went through a whole bunch of thinking about this and trying to figure out if maybe there were doorbell wires behind where I was trying to put it. And long story short, I ended up deciding that I would power it with a battery because I looked into low power stuff with Arduinos, and you can actually get these things. Because there's electronics out there that when they're not being used, they're essentially using no power. So I figured it must be possible.
Right.
So I did enough research into it to know that it was possible. So then I started putting this together. I hooked a battery up to the Arduino. Or maybe the battery came later. Maybe I was just testing the current draw at this stage. So I looked into low power. There's a lib for that called low power, aptly named.
Yeah, they make them so hard to find, don't they?
Yeah, it was incredibly difficult to find out of all those libs. Having a lib is great. It can get you most of the way there, but you still have to, if you want to make a 150 milliamp hour battery out of your old RC helicopter, if you want to make that last any length of time that doesn't annoy the heck out of you having to recharge it all the time, you're going to have to really dive in. So I went on a whole week or 2 week long process of just researching different ways to get Arduinos to do low power and how to code for it and everything, and ended up getting it down to, I think it was in the microamp range. So I got this thing to draw I got it to draw probably 100 microamps when it wasn't running. I have a picture on Instagram somewhere saying, "Yeah, I finally did it," and showed the 100 microamps on the meter.
That's really impressive.
Yeah, it was impressive at the time, or I was proud at the time, and it's impressive to me now thinking back to it. And what had to be done to also make a very long story short, is I cut the lead to the LED on the Arduino because that thing draws 10 milliamps, which is how many times greater is that than 100 microamps?
Oh, you're asking math questions, but that's 100 times?
At least 100 times. I'm pretty sure it might be 1,000.
I'm going to have to look at a picture, but it's a lot.
Yeah. So we have an LED on the board.
I have an answer for this. George would know.
There we go. Where's George when you need?
Not here.
Yeah. So, 10 milliamps out of the LED when you're talking about low power and running this thing for a month is that's huge. You're going to run out of power on a 150 milliamp LiPo cell. You're going to run out of it. Well, you're not going to get 150 milliamp hours out of it, first of all, and second, it's going to be less than 10 hours. And if I had to go charge my doorbell every 10 hours, I'd just go crazy. So I cut the lead to that on the circuit board. That was the easiest way to disable that. It's just a power LED, and did a bunch of other things with the low power lib to get turn as many things off as possible on the Arduino. And the way you make all that work is interrupts. There's certain pins on the Arduino that I think most of the pins will drive an interrupt on the Arduino, but there's only a few pins, if I remember correctly, that will actually wake it from either sleep or power off state. So I used one of those pins with my button and basically I can't remember if I put the Arduino into deep sleep or just completely power off, but something that basically shuts off pretty much everything the Arduino might be doing. It just completely just goes to sleep and then some. And that's how I solved the transmitting end. And with all that going down, I got battery life of at least 4 weeks, which, it's still annoying to pull the thing off of there and go charge the battery. So I started thinking about solar panel solutions. Never got around to solving that, but probably at some point I'll add a solar panel and get it to charge itself.
If you wanted to be really cheeky, you could install, I don't even know what it would be called, but install some type of contraption that you actually have to press the doorbell 20 times to charge it enough in order to get it to fire off one event.
I love that. It's funny you mention that because we have some pretty close friends whose daughter loves to ring the doorbell over and over and over again. And I used to, every time she'd come over, I'd be at work or something like that. She'd come over and visit my boys, and I'd get one or two texts saying your doorbell's being rung, and I'd be like, oh, okay, she must be over again. But she'd push the button over and over and over again. So she would successfully send the message, but nobody else would, because they'd press it twice or maybe once, and
just give
I
up.
would never have to hear about it, which is just fine. Yeah. So that's the transmitting end of things. So now I suppose I could talk about the receiving end of things, and this is where things are probably more complicated than they need to be due to my extremely cheap choice of RF link.
Just so you know, I've looked them up since we've been talking. You got a good bargain because they're now up to $350.
Okay.
Shipped from China.
So expensive.
I know.
Yeah. So with this RF link, I assumed that I could get the Raspberry Pi to receive this information. I had a Raspberry Pi laying around doing stuff. Actually, it was in charge of monitoring the state of my garage door, whether it was open or closed, and changing that state should I command it from my mobile phone. That's a whole different interview. But I assumed that I could take this RF link and just send the data straight to my Raspberry Pi and do something with it. And with a credit card size computer. You can do pretty much anything you can program. That didn't turn out to be the case because the Raspberry Pi is not it's not a microcontroller. It's not doing computing in real time.
Yeah, it's not a real time system.
Yeah, exactly. And with ultra simple RF link, you have to dedicate your system to monitoring what that RF link is doing. If data comes in, you have to be ready to receive it. And maybe the most powerful computer could have an entire processor out of its 16 or 32 processors dedicated to that task, but a Raspberry Pi can't dedicate its processor to that task. So I had to use an Arduino on the receiving end.
Yeah, so I mean, when we're talking about this, in what you described in email to me, part of your challenge was there's no forward error correction on this message. There is no built-in repeat or anything. It's literally the message gets fired off.
Yep.
And if you're not there to both receive it and decode it, then too bad, Charlie. You're out of luck. So in this particular instance, I'm assuming the problem that you had to solve was that with a Raspberry Pi, you had to be lucky if the message arrived at the Pi at the same time the clock cycles were being spent to sample that input.
Yep. Exactly. Yeah, and that's why. So there's a lib to handle this transmit receive combo on Arduino, but there isn't a lib on Raspberry Pi to do it. And I could write my own, but like you just said, I'd have to hope that I got one of the bytes that came in out of at least 8 bytes.
Now, out of curiosity, what speed is the message being sent?
So that's something I played around with, and I'll just go ahead and dive into the next challenge that I faced, which was the distance between my doorbell and the receiver. I had my Raspberry Pi and this other receiving Arduino in my garage. It's not a huge house, but radio waves are funny things, and they don't like houses that have plaster and basically mesh holding on.
Yeah, that's usually wire mesh. Your walls are basically parts of Faraday cages.
Exactly, and the outer part of the house, stucco almost always has wire mesh holding it on. So I had quite a few obstacles for RF between my transmitter and receiver. So the first thing I did with my newfound ham knowledge was put a little antenna on my transmitter that was a quarter wave little wire sticking out the bottom for 433 megahertz. I can't remember the length of that, but again, George could probably tell us just right off the bat. He could probably say, oh yeah, that's 7 inches long. So I put a wire on the transmitter because let me step back a little second here. So one of the reasons I chose the 433 megahertz transmitter as opposed to the 315, and I'm not honestly sure at this very moment which one is actually mostly legal in the US, but I chose the 433 because I could tune my new ham radio to that frequency and test whether there was something coming across the airwaves.
Well, so one of the things I would say, because I don't know if this was available in I think it's 915 megahertz, which is where the American ISM band is. 433 is generally the ISM band in Europe or the EU specifically. Now, I have seen devices like weather stations sold in America that use 433 to transmit data from the little weather sensor on. But quite honestly, as long as in your packets you're sending your call sign, you're probably okay.
I will now.
That's what we're here for. We're here to help.
Yeah, exactly. It's funny that I didn't think of sending my call sign in the packets at the time. I have a data packet that I'm sending with this doorbell transmission, but I didn't think of a call sign.
Yeah, you're not. It's not like you're encrypting the data for.
Yeah.
And oftentimes a lot of these receivers, I don't know, I'm looking at this thing and man, you're not kidding for simplicity. It's, there's the receiver itself looks like it's basically just an inductor with 3 pins. Like it literally is a receiver, and it just passes the voltage received on down the pins via analog. I don't even think that's digital, is it?
It's I think it does give it analog information, actually. Yeah, and you get a lot of noise with what you're receiving. You actually have to filter that.
Yeah, so I see one IC on, because I'm assuming the little square board is the receiver.
Mm-hmm.
And
the rectangular one is the receiver.
Okay, then I'm getting it backwards. Yeah. The receiver actually has a lot more components on it, but the transmitter has like 4, and one of those is the header pins.
Yeah. Yeah, the transmitter is a crystal and
couple of inductors.
Yeah, that's just about it. Yeah.
Just to ask the question, and maybe the library takes care of this, but what do you set the pin to that writes to this thing?
Boy, the library takes care of it. The library takes care of it, so I'm giving it a data packet. But I did play around with the straight interface a little bit, and I think it is giving it. It's not giving it analog values. I think it's on or off. It's on or off.
Okay. And then I guess the receiver then is the one translating translating what it is sending.
Yeah. Yeah, exactly.
Because I noticed in the data, it doesn't exactly say, like you said, it was amplitude modulation, but it doesn't even say what that is. It says it's 10 milliwatts.
Yeah. Yeah. So the power range is, it's in the range of not being an issue. It's totally that ISM power. Very, very little power. It's a very, very simple combo, and the transmitter really is just I'm pretty sure it is just a crystal and a couple of inductors.
Yeah, and you're not getting the 10 milliwatts out of it because This is actually a question on the transmitter side. So it says that operating voltage is 3.5 to 12 volts, and that the quote unquote launch distance is dependent on the voltage. It says different voltage, different results, which I love that. But clearly, if you were operating this thing, like if you had a transistor switching it instead of doing it off a GPIO pin, you're probably in a higher power output. Yep. What voltage is the battery you're using? And is it around a 3.4?
Yeah, it's a LiPo cell, so the nominal voltage is 3.7.
Okay, so that Arduino is a 3.3 volt Arduino.
Yeah, it's actually the Pro Mini that I got. It's the Chinese version of an actual Arduino Pro Mini, and it's selectable 3.3 or 5 volts.
Cool. Okay.
And I set it up for 3.3. Or maybe did I set it up for 3? I think I set it up to be 3.3 volt logic, and the 3.3 volt is actually very tolerant of the voltage that you power it with. I think that's how I did things, because I didn't do any power regulation or power control or anything like that.
Gotcha. Yeah. So if going back to the comment about sending your call sign, if the library offers like a CW mode, if you were to just throw your call sign in after the bell rings on the quote unquote CW mode, you would definitely be good.
Yeah.
Probably. Yeah. Trust me, if you're not, we will hear about it.
Yeah, I think we will. So I think any modulation that isn't encrypted, I think we're good. If I send my call sign, we're good to go. And I am open to comments on that. So I hope we see what we get there.
Well, to that point, you are active on Twitter. Your handle is?
It is Rex Vokey. So first and last name. I should get a call sign Twitter handle on there. I seem to mostly tweet about ham radio stuff these days. But if you want to, anybody out there, if you want to give me comments on the legality of sending a call sign, I'm pretty sure I'm doing it's totally ISM stuff here, but I really would love to hear. Although I'll probably know by the time this quote unquote airs, I'll have researched the subject thoroughly, and I'll be doing exactly the right thing. But it's a great point for discussion anyway, because not only would it be good to know whether I should be sending my call sign on that frequency, but I think just for the sake of having my call sign being digitally transmitted by my doorbell, I'm going to do that. just for the fun of it.
Well, there you go.
Yep.
So, I'm sorry, I took you off track many, many, many ways. I have one more question about the transmitter that came up before we get back to the receiver.
No worries.
Debouncing. Do you want to describe to listeners what the debouncing problem is?
Yeah. So when you push a button, it is a mechanical process, and not only are there a lot of crazy interactions happening at the microscopic level, creating that electrical connection, but you might have a shaky finger and push the button a little bit shakily, and so the button may quote unquote bounce several times within just a few tens of milliseconds when you push that button, and that can be a real problem when you're trying to receive the digital state of that button. You might receive a digital state of on 10 or 100 times when that button is pushed. Am I pretty much right on the right track there, Jeremy?
Nailed it.
Yep. So,
and of course, there are two different ways to debounce a button, either using electronic components, but I also understand that in the Arduino world, you can software debounce a button.
Yes. So there's I can't remember, because it's become such a common problem to solve. I can't remember if it's a library that you have to use, or if the Arduino now handles it for you. I may have some debouncing code in this whole thing, or I'm probably using it. I'm probably using a debouncing library. So it takes that input and it'll either it'll take the first rise of that digital pin, and it'll say it's on now, and create a delay and not accept any other changes of state for a certain amount of time. That's the most simple way to handle it. And you can actually write that on your own. And it's actually fun. If you're getting into programming on an Arduino, I think it's great to go ahead and write the code to make the LED blink when you first get this thing going. But I strongly recommend trying to solve that problem next. If you get into programming your Arduino and want to solve a real problem, think about what you need to do to make that button trigger once when you hit it, because if you just take that digital input directly, you'll see the bouncing problem right away, and try to program around that and see what solution you can come up with, because there's more than one way to handle it. But I used a library, and I have programmed around the bounce. I've done debouncing code to handle that, because you go push your button when you get this thing put together, and you go, oh, it fired like 20 times. Oh boy. And it's fun, but it's not quite what you're looking for.
Yeah, I'll put Dave Jackson, or not Dave Jackson, wrong Dave. Dave Jones from the EEV blog, in a part of setting up for a series to debunk the batterizer, he had to debounce a monkey. You know those monkeys that clap cymbals together?
Oh, yeah.
Yeah, he did a video where he wanted to count every time the cymbals clap together, so he had to handle debouncing, and he hooks that up to a scope to show what it looks like. So I'll put a link to that in the show notes.
Oh, that'd be great. Yeah, that's the best. Seeing it on a scope is the best thing. Actually, seeing anything on a scope except for DC voltage is just exhilarating, in my opinion.
Hey, it was an oscilloscope that made electronics accessible to me, because then I could actually see what was happening.
Exactly. Yeah. It's amazing. I actually don't have an oscilloscope right at the moment, and I'm pretty sure I'm going to try to find one. Kind of try to find a little swap meet deal soon, or something like that. Get myself an analog oscilloscope. I mean,
given where you live, just drive around to dumpsters, man.
Yeah, exactly. I've heard you and George talk about Silicon Valley dumpster diving in previous episodes.
That's primo dumpster diving.
It is. I should definitely take advantage of that. So I'm sidetracking myself now, but you touched on another subject for me, which is this whole electronics and ham radio thing. Kind of started at a really early age for me, which My father was in the Navy, and he became an electronics technician in the Navy, and when he got out, he started his own electronics repair shop, and that's not really a thing now. People don't repair things, but back then they did. And I grew up around this stuff. I didn't go to school for it or anything, but I grew up around electronics, and I knew how to use an oscilloscope by the time I was 10. I had my own multimeter and tried blowing up capacitors as a kid. That was my idea of fun. So that's a little bit of background I forgot to mention earlier on.
Outstanding. All right, let's get back to the receiver.
Yes, the receiver. So the rectangular receiver, which is still doing a very basic function of passing analog RF data on the 433 megahertz frequency. I don't know if it's actually exactly 433. Irrelevant. So we take this analog information, and it's mostly noise. Anybody who has worked HF and even turned the squelch down on their FM ham radio has heard plenty of noise, and that's always there, and your receiver's always going to pick it up. And what does a digital device do with this?
It makes things up.
Yeah, it does. You get a lot of information out of this noise. And if you take this RF module, this RF link module, and you plug it in and you just try to get data straight out of it, you'll get plenty of data. Lots. It's a good random character generator.
Exactly. Especially considering that noise is like the background entropy of the universe expanding.
That's right. Exactly. So you could do you want to do a random number generator, use this as your input for that random number generator. So you have to take any actual signals that might be occurring in this noise and filter them out and do something with them, and actually maybe even get some information out of them.
You have made this really, really hard, haven't you?
Yeah,
like you said, things. This is what $1 will get you.
Exactly. You can spend $1 and get one of these things, or you can follow George's advice and spend $15 or $20 and don't even think about any of this. But so we have a bunch of noise we're receiving, and there's a library that handles this. Fortunately for me, there are people like myself and maybe even more generous that have created libraries that will grab this data out of the ether and the noise and make sense of it.
Is that still part of Radiohead, or is it a different library?
This is Radiohead. This is a receiving end of Radiohead.
Oh, sweet.
Yeah, different parts of Radiohead. I think on the transmitting end, it was Radiohead amplitude shift keying, and then on the receiving end is some other, couple of other modules, probably amplitude shift keying and some other receiving thing. So that started receiving my data, and I realized that I was getting part of my message sometimes. So I wanted to make sure that it was my doorbell being pushed, and I'd send along a code. I said door 6686 or some number, some distinct number that verified that this was my button being pushed. And sometimes I'd push the button, and you only get one shot usually. People are usually only going to push the button once. I'd get my message partially sometimes, and that's not going to work. So I ended up going the very, very simple route on this, and I just told my transmitter to send the message 3 times. My own form of error correction.
Hey, there's nothing wrong with that. There's some digital modes that's basically how they're able to get such good signal to noise ratios is by repeating the message, if I'm not mistaken. And on field day, the way that I improve the signal to noise ratio is by saying my call sign 3 times.
Exactly. I was just going to say that. I'll often say my call sign 3 times so people get it. So pretty valid, very simple. It's often best to use the most simple solution if it's going to get you to where you need to be.
Now, you know what's handy, though? I know you got a unique identifier for the door, but you throw your call sign in there, and you have another key to authenticate that the message is yours.
That's right. Yeah, then I know it's not somebody else saying it's my doorbell. Yeah, so
that'll be the next thing. It'll be door spoofing.
Yeah, that'd be something, wouldn't it? It'd be the Ding Dong Dash thing. It'd be a whole other level of that. Just driving by, just ringing all the doorbells. So I used a library to receive that data, and then I started sending it 3 times. The next problem to solve was what do I do with those 3 messages? If all 3 of them come through, am I sending? The whole point of this doorbell is to text me when the doorbell gets pressed. So am I going to send 3 texts to myself and my wife every time somebody rings the doorbell? No. So I decided to keep things simple on the Arduino side, and the receiving Arduino ended up being a simple, just receive this data and pass it along to the Raspberry Pi through the serial interface, which, you can do a lot with an Arduino. You can actually, I know that there are certain Arduino projects that that are able to serve web pages if you get a network interface hooked up to it.
Yep, I've got it's an Arduino. It's called I think the MKR 1000, and it is their new SAMD 32-bit ARM-based microcontroller with a built-in Wi-Fi chipset. So there is a URL on my network in the house that if you hit, it will turn the LED on and off.
There you go. Exactly. So I could have done way more with the Arduino on the receiving end, but I am most familiar with programming things in a non-real-time programming environment, and I had a Raspberry Pi sitting there. So I plugged the Arduino into the Raspberry Pi and set up a serial interface. And I used Node.js code on the Raspberry Pi. I don't know how many listeners will be familiar with that, but it's a programming language. It's JavaScript. You've probably heard JavaScript before. And Node.js is a method of using JavaScript programming, to put it simply, to do things on the do things outside of the browser, do actual programming and make actual applications and that sort of thing. So I have my Raspberry Pi listening on this serial interface for this distinct message from my transmitter, and it'll receive, the first time it receives a message, it'll set a timer and say, okay, I've received a message. I'm going to send the text now. I'm setting a timer saying I don't want to do this action again for another 15 seconds. It'll send it hooks up to an SMS gateway. I use Twilio in this case. Hooks up to an SMS gateway and sends a message off to myself and my wife saying somebody's rung the doorbell. And then it resets that timer after 15 seconds. So if somebody presses the doorbell again, that can all happen over again. And that's pretty much it.
Now, is Twilio free to use?
No, I think it's free for a month. There are free SMS gateways out there, but I happen to have some money on a Twilio account already for some other project I was doing and messing around with. I think it costs probably 1 cent or 2 cents to send one of these texts.
Oh, that's not bad.
Yeah.
And I know, I guess I don't know if they're around anymore, but back in the day, before all the kids were texting and tweeting at each other, every major mobile provider had an email to SMS gateway that was available for free. Mm-hmm. So you shoot an email at their server, and I think the 2 was going to be the phone number, and then I think it ignored the subject, and then the body of the message would get SMS'd to the phone.
That's right. Yeah, that actually still exists for most providers, and sometimes I wonder whether these SMS gateways are just doing that. They probably aren't. These are serious businesses. But if I were to set up my own simple SMS gateway for myself, it would use that. And in fact, Jeremy, I think at one point when I was testing this stuff, I did just use a straight fire off an email to my SMS gateway. Actually, I may have even just done email at first to test all of this. But once I got to the point where I wanted to reliably send these messages without triggering spam filters on the on the email to SMS gateway, I decided to go with an actual SMS gateway. But for testing, it's totally valid to just go ahead and use one of those email to SMS gateways. You can usually Google T-Mobile SMS gateway or AT&T SMS gateway and find out what the email address is.
Well, what's interesting, not the SMS part so much, but at this point, either with the Arduino or the fact you've gone to a Raspberry Pi, if you wanted to, you could have still like audio visual alerting in the house, i.e. a doorbell chime, and then set times for which, if it's between this hour and this hour, don't do it, etc. So, I mean, you still have a lot of options, to play around with this. Like, what are some of the things beyond this? Like, it's like you've got the proof of concept working.
Yep.
I mean, tonight we have solved your power problem on the button with the new, friction power generating interface. For that matter, you know how in hybrid and electric cars there's regenerative braking?
Yep.
We're going to invent a regenerative doormat.
Absolutely. Just stand on the doormat and it will generate the power for your doorbell ring. And you get a little ride. It goes down, 6 inches every time you stand on it. You get a little ride. What's happening? Oh, it's just the doorbell, regenerating. Yeah, there's a lot of places you could take this. It was interesting to see, because I tell my friends about this while I'm working on it, and a couple of them were interested in getting a little bit involved in it, and didn't really materialize. But there's ideas that come back to you when you think you've got your genius idea, and then somebody says, "Oh, good. When they've rung the doorbell, can you then talk to them?" And I said, "Well, no. That would be really amazing, but I don't know how I would make that happen with my power requirements." And then, when they ring the doorbell, can you get video of them? And I said, well, yeah, that would be really great. And then, a week later, the
Ring gets invented. Yeah.
Yep, Ring came out, which I was really happy to see. And I really want to get one of those. I'm totally happy to replace my doorbell project with that. It's a really nice product, and they solved a lot of problems. I immediately looked into how they solved power, because not everybody has a wired doorbell. And what they did? They put a giant battery in there.
Yeah, I mean, the unit itself is fairly large.
Yeah, they put a 5 or 6 amp hour battery in there, I think.
Still no way to... Well, actually, I don't know how you recharge it. Maybe you bring it in at night and plug it into USB or something.
Yeah, it lets you know when its charge is low. Yeah, so I looked into that because I was like, oh, okay, they were working on that while I was working on this, and here we go. But yeah, so I have a little buzzer that beeps each time there's a message received on the Raspberry Pi end. So actually, no, it's the Arduino that does it. So it makes a sound on the buzzer every time somebody pushes a button. But that's over in my garage, so we don't really hear it. But there's totally an opportunity for visual and audio indicators. And like you said, I can program this thing to work within certain hours. I can have it perform certain other actions based on the fact that the doorbell is being rung. There's a lot of other IoT opportunities now as well with things like Alexa and Google Home that this could tie into. Yeah.
One thing I'll add about that, and this is just because I'm on a personal crusade about this topic. Since you dropped IoT, where we're gonna you hit the first word in buzzword bingo.
Yep.
One of the things is that it's all well and fine that right now it's a very simple proof of concept and whatnot, but as people start building this tinkering stuff, you got to start thinking about security a little bit.
Yep.
Just a little bit.
Yep.
So
totally.
that's my soapbox. I'm not going to tell you what that means, because obviously that's an entire show.
It is.
Securing the Internet of Things.
And just as a little hint, I don't know if you want to go down this road at all, but as just a little hint to anybody that's listening to this, what was that attack that was recently done? There was a massive
the DIN DNS was done because of people not changing the default accounts on their like webcams or DVRs.
Yeah, that was a massive denial of service attack carried out from your little devices, most likely. There's somebody out there listening to this that had one or more of their devices participate in that. And the sheer quantity of devices makes that very, very, very appealing thing. And the lack of security on the devices makes it very appealing for that sort of attack. But we won't go too far down that road. But when I was putting all this together, and when I put my garage door controller all together, I was already thinking with that sort of level of security. And also, with the garage door, I didn't want anybody opening my garage door
obviously
without my permission. So
yeah, so that's another option then for the transmitter and the button is to put a fingerprint scanner to find out if you're authorized to ring the doorbell.
Ooh, I like the ideas you're throwing in, Jeremy.
Just get some old busted iPhones, and you can get the little the ring reader, and there you go.
Perfect. I like it.
Well, Rex, this has been awesome. I like I said, I really liked this project because you had to solve a lot of problems. It was very clear that you had grown as a person as you had done this.
Absolutely. Yeah.
So what's going to be on your workbench next? Are you going to continue to build this thing out, or have you already found the next great project you're going to work on?
That's a big question, man. Well, as soon as I clear off the workbench, as soon as I clean it up a little bit, which I think we're maybe all in the middle of it at
any given time.
Yeah. So I finished my antenna analyzer build, which was very fun, and I love that antenna analyzer. I want to probably get that back on the workbench at some point, but for now it's sitting off to the side. You doing this interview with me has made me want to get I'm going to do a couple of upgrades to this doorbell. I'm going to get a more robust power system for it. I'm going to get a new battery put back in there and get some solar power going for it. And I'm going to keep using it until I get something that does have video like the Ring. And I will probably tie in some further, actions that tie into the doorbell happening and that sort of thing. But probably beyond that, the next thing on my workbench will probably be whatever you guys are working on that you're kind of keeping. You've hinted at it.
I'd say I think we've been pretty transparent because with the. When we did the antenna analyzer, I'll at least speak for myself. I wanted to be as transparent as possible, but it was one of those things where none of us had ever actually launched a project like this before. And even though we were using K6BEZ's work, Barrick had done a fantastic job. This project had lasted for a while. I was just one of those. It's like you always hear about people launching projects like this and what an abject failure they are because, there's no support or the boards never arrive or the thing's wrong and people don't answer emails and whatnot. And once we had successfully launched it, we were like, okay, well, we're going to be fully transparent about the second project, which is going to be it's a power. I'm going to call it a power device, and this is a device that I have wanted for a long time, and it combines power monitoring functions that you would find in like a What's Up meter or a power check from West Mountain Radio. So you get voltage, current, power in watts and milliamp hours as far as tracking total energy consumed. And then you can do a min-max average of all those things if you wanted to. In addition to that, there's a low voltage disconnect, which will be, basically there to protect your batteries, right? And, it'll be programmable to set, is it a lead battery or a lithium battery? And you can set what the disconnect points are and what the reconnect points are. And do you have a button that lets you do an emergency override? And then now we're looking into adding basically like power gate functionality where if you had this thing at home, you could have a power supply in one side and a battery on the other, and it would automatically fail over, but you get complete monitoring of your power usage at any given moment.
Absolutely.
So yeah, that's the next thing.
That's the next thing on my workbench then, Jeremy. That's when I heard low voltage disconnect when you guys first started talking about it, I was like, yeah, all right, I guess so. And then you started hinting at other features, and that's totally going to be, I do a lot of portable operations, and if there's something I could build that would go in between my battery and my radio and tell me what's going on with that power, I'm all about that. I love to see the numbers. I love to know how much time I have left, that sort of stuff.
Well, I will not quite giving you like the numbers, because I mean, what we're going to build will be Arduino based, and if you want to build like operation timers in it, you'll be able to. But there is one thing that this will be the second time in one of these user project interviews I mentioned it, but as somebody pointed out to me, Buddy Pole has released a device called the Power Mini, and it is basically like a QRP version of exactly what I just described for $140. Yes. So it, basically it has an OLED display to show you all the power statistics I just mentioned. It includes a user-definable low-voltage alarm and cutoff. It has a built-in solar charge controller to handle panels up to 10 amps, and it is pulse width modulation charging, not maximum power point tracking. And this device is actually, I called it a QRP, but it's actually designed to handle up to 25 amps. So that's a 100-watt radio in the field.
Yeah.
For $140, like this is definitely on my buy list at Dayton.
Wow.
Assuming, although I have anytime there's a power thing that comes out that I'm really excited about, the manufacturer never brings them to Dayton. So I may end up ordering this before Dayton, but for $140, you can't miss it. In fact, since we're talking about, I'll make sure to put a link in the show notes.
Absolutely. That sounds amazing.
While we're talking about show notes, I'll share with you. I intentionally left a link out of the show notes last time to see if anybody ever reads the show notes. I guess I could go look at our web analytics, but, usually again, if they're, it just like with the call sign in the 43rd, we're going to hear about it.
Oh yeah.
If it's a thing.
Yeah, absolutely. I often get to the show notes if I just can't remember the name of something.
So, Rex, before we go, are there any tips or tricks or encouragement or knowledge that you would share with our listeners as they're sitting at their workbenches?
Yes. Well, I mean, boy, there are so many things, but I think the biggest thing, and I think this is a pretty obvious one, is to just get in there and just do the project. If you have an idea, just get in there and start doing things, and you'll end up on the other side with something. It may not be exactly what you originally planned, but just get in there and start doing it. And also, if you're putting together anything that you really care about when you're soldering, do some practice soldering before you dive in there and burn everything to death.
Just out of curiosity, what are you soldering with?
I have, since I started this project, changed soldering irons, and I have a Weller soldering iron now. That's it's one of those. It's one of the basic adjustable Weller soldering irons. I don't remember the model.
Something 51.
Something like that, I think.
Yeah, that's like the Hakko, the Weller Hakko competitor, and there's something it doesn't do, but if I remember correctly, it actually does have an automatic shutoff built into it, at least. Which
no automatic shutoff on this one.
Okay,
this is the red one. This is the red one with the base, and it comes with a sponge and.
I got you. Yes, that is not the
50 watts.
That's not the WES or whatever 51.
Right.
Okay.
Yeah. So it's a really basic one. I do have to remember to turn it off. So
that's a pro tip. Shut off your soldering iron.
Yeah, that's definitely a pro tip. You got me really wanting the Hakko model that's around 100 or so.
Yep.
I'm pretty sure that'll be one of my next, after I get the oscilloscope, that may be one of my next Workbench purchases, because you really get into how that soldering iron functions for you when you do a lot of this. Oh yeah, and it's actually, when talking to another listener, we both admitted to each other that soldering iron made me realize that that I had been soldering wrong my entire life. Like it was a transformative experience. Oh boy. Yeah.
Well, Rex, I want to thank you so much for taking time out of your Oscar party and with your friends to spend with us here on the Ham Radio 360 Workbench. We will check back in with you sometime in the future. And of course, you and I are connected on Twitter and kind of speak often there. But thanks again for taking the time. Thanks for sharing this awesome project with us. And have a wonderful evening.
All right. Thank you very much, Jeremy.
I want to take the opportunity to thank all of our listeners again who spent their time sharing their projects with us. It is, again, as I said before, very humbling to see the creativity and talent of the folks who choose to spend their time listening to us. I mean, we really are pretty lucky, George.
We are. We have a great group of listeners and very inspirational. And I love listening to people talk about their projects because you always walk away with some idea of what to do. And it may be build exactly that. Do you know the first time I ever heard about this guy, Jeremy, KF7IJZ?
Who's that guy? He sounds like a jerk.
No, he's a pretty nice guy. Well, it turns out before I ever met this guy, I saw your YouTube video on your solar panel analysis and then your build project of putting together your orange Pelican case with the lithium iron phosphate batteries and all that stuff. And it was really awesome because when I saw your video, I thought, that guy's figured it out. That's exactly the set of stuff that I would buy to build my portable power pack had I known that. And then I proceeded to build exactly what you built. And then it was like, I don't know, a year later that Kale introduced us. So that was a fairly serendipitous event that we got to know each other after the fact, but you inspired me to actually go out and build exactly the thing that you built.
That's awful sweet. I've never built mine, though, George. Mine is literally still a box of parts.
Boy, your video looks like it's built.
Yeah, well, that's the thing is I still, to this day, I think I've mentioned this before, I get emails about once every week or so saying, when are you ever going to do part 3 where you actually build the box? And then oftentimes I just point them at your blog.
Well, you know what's funny is that I mentioned earlier that we're going to run our 20-meter field day station on an IC 7200, and that orange box, the KF7IJZ Special, is the power source for the 20-meter station at field day.
Outstanding.
Yeah, so it's great, and we're going to plug a big 120-watt solar panel into it, and use the Genasun solar charger and the prismatic cells, and exactly everything that you outlined. So, yeah, thanks for that.
Well, you're welcome, and thank you again, listeners, for sharing your projects. We will do another call here in a couple of months, probably after Dayton for sure, because I think it actually would be good a couple times a year to check in with you guys to see what you're working on and share your ideas. I mean, again, talking through Rex, him having the problem with deciding how does he ID while talking from the doorbell to the Raspberry Pi inside, and us, coming to that solution, which was so obvious to me, but even he as an experienced ham didn't see that. I mean, that's the entire point of these conversations, right? It's inspiration, and it's understanding that you can't necessarily come up with all the solutions yourself, and that's one of the reasons I'm very thankful, A, to get to spend this time with you guys, and B, to actually be part of, Kale says it all the time, but this amazing hobby, and it truly is.
It really is. Thanks very much, everybody, for listening, and keep active on Facebook. And stay in touch and see you at Dayton.
And I always give this shout out, so I'm going to do it again. If you are interested, you can follow me on Twitter. I am at KF7IJZ.
And I'm at KJ6VU.
Again, there's the Ham Radio 360 Facebook group. And of course, you can follow everything that's going on at www.hamradio360.com. I will say before we go, if you have not had a chance yet to listen to Kale's interviews with Eric Guth from the QSO Today podcast, or with Kenneth on the episode following up on APRS questions, definitely go give those both a listen, as they were phenomenal shows.
Hey, I have a little special thing I want to mention.
Is it a secret?
Not anymore. So after the episode with Eric Guth, we emailed back and forth, and he suggested that an all-star node would be a really good Workbench build project. And I thought that was a pretty cool idea. So I'm curious if other people out there would find that interesting. If so, maybe we'll do that later this year. So we'd love to hear your feedback. And if you haven't listened to that show, I highly recommend it. And Eric's show, QSO Today, is a fantastic podcast. He interviews really great people. and I find every episode really very informative and really good. So you should definitely check that out. That's it.
That's it. I almost said that's all, folks, but I'm pretty sure we can't say that.
That's all, folks.
All right, 73, everybody.
73s. So for the rest of the show, Jeremy, why don't you give us a quick rundown of the build projects and the interviews that you did?
Well, I'd be happy to. I guess you're not going to tell me what's on your workbench?
Beep, 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 beep.
I downed an entire 2 liter of real Mountain Dew. I don't really drink much soda.